Hello there, and welcome to Secretum Histories, a place where big ideas find quieter voices and the edges of old stories soften into something easier to drift through. Tonight's journey settles into a topic that has lingered at the margins of ancient records, whispered through symbols, carried in fractured memories, and woven into the cautionary tales of civilizations long gone. It is the idea that Earth has not always travelled its cosmic path alone, that somewhere far out in the dark, moving on a slow and solitary arc, there might be another world. A world that occasionally comes close enough to stir the seas, unsettle the crust beneath our feet, and leave behind impressions strong enough for ancient cultures to record them with the tools they had. A world that some have come to call Nibiru. It is a name loaded with speculation and imagery, carrying echoes from clay tablets and myth cycles, and brought into modern imagination by attempts to understand why so many ancient stories describe upheaval that arrives in patterns, not random, not senseless, but recurring, sometimes subtle, sometimes overwhelming, yet always remembered in ways that seem to hint at a rhythm older than writing. This idea has drawn people for generations because it offers a unifying thread through tales of floods, fires, migrations, collapses and recoveries. It suggests that the planet we stand on may bear marks from encounters with a visitor that takes far longer to complete its path through the solar system than anything we can observe with casual glances at the night sky. Before we drift deeper into this topic, I'd love to know where you find yourself tonight, and what the hour looks like in your part of the world. These small details bring a sense of presence to a subject that spans continents and millennia, reminding us that even as we talk about enormous timelines and cosmic influences, we are still individual people listening from quiet rooms, dim corners, parked cars or warm beds. And if this gentle exploration feels soothing, intriguing, or simply a pleasant companion for winding down, it would mean a lot if you gave the video a like and maybe subscribed as well. These small actions help bring this cozy corner of curiosity to others who might enjoy settling into a story at the end of a long day. So let's begin, not with any attempt to solve the mystery outright, but with a simple consideration of how deeply ancient peoples tried to make sense of the forces that shaped their world. When we look at early civilizations, from the river valleys of Mesopotamia to the terraces of the Andes, we see that they lived with a constant awareness of the environment around them. They watched the sky for patterns, tracked the seasons with precision, charted the rise and fall of stars, and recorded the calm and calamity that shaped their lives. This attention to the heavens was not just spiritual, it was practical. Agricultural success depended on it. Survival depended on it. And in the stories they left behind, we often see descriptions of catastrophes that felt too large to be explained by local storms or river floods. These accounts describe upheavals that seem to come from beyond Earth itself. Across cultures, the writings and carvings and oral traditions often describe sequences of global or near-global events that arrive in intervals. Massive floods that erase coastlines, fire from above, great winds that reshape landscapes, endless winters that follow years of dust and ash. Civilizations recorded these events with the language they had, often wrapping them in mythic imagery, yet leaving behind a core impression that something vast had swept through, altering the world and forcing people to rebuild with whatever remained. When modern researchers compare these accounts, patterns begin to appear, not identical, not perfectly aligned, but consistent enough that some wonder whether they might reflect real cyclical disturbances in Earth's environment. This is where the concept of Nibiru enters the conversation, not purely as a mythic home of gods or a legendary realm spoken of in ancient epics, but as a hypothetical object whose path might intersect or approach Earth on an immense timescale. A world with an orbit so elongated that it spends most of its time far beyond anything we can easily observe, only returning at intervals so long that no civilization has had the tools to track its full cycle. The idea suggests that when this world returns, even if it never comes close enough to physically collide with Earth, Its gravitational influence alone might be enough to disturb comets, shift smaller bodies, or create tidal and tectonic stresses that build over centuries before releasing their energy in catastrophic ways. It is a speculative idea, but speculation has always been part of human attempts to understand the past. When we do not have complete records, we look for clues in stories, in geology, in astronomy, and in the remnants of societies that endured sudden upheavals. And as we piece these fragments together, the notion of a recurring influence from a distant object begins to take shape, not as a definitive explanation, but as a possibility that invites examination. Consider how ancient cultures described their world. They did not use timelines the way we do today. They did not number years with global calendars. Instead, they marked time by events, rulers, seasons, and the cycles of the sky. When something extraordinary happened, they recorded it through stories that carried both fear and reverence. Floods were not merely natural disasters. They became symbols of renewal, destruction, or divine intervention. Massive fires were framed as battles between celestial beings or expressions of cosmic imbalance. Long winters or darkened skies were presented as punishments, trials, or phases in a cycle beyond human control. And in these narratives, there are traces of something larger than local events. As we sift through these echoes, we see civilizations describing upheavals that seem too widespread to be local storms. They speak of seas rising with such force that coastlines vanish. They speak of fire that comes from the sky, not in isolated streaks of lightning, but in sustained events that leave behind charred layers in the ground. They describe ash that drifts across the land for years, turning daylight into a dim glow. They recall periods of cold that endure long after an eruption should have settled. We now know that volcanic events, asteroid impacts, and shifts in global climate can produce these conditions. But some researchers note that the timing of these events seems to fall into rough patterns that raise further questions. For example, several major known catastrophes in geological and archaeological records appear to occur in clusters separated by long intervals. These intervals are not perfectly even, but they fall into ranges that some find intriguing. When viewed alongside ancient stories that also describe recurring cycles of destruction, a picture emerges of a world influenced by something beyond local conditions. Add to this the possibility of cometary influxes triggered by distant gravitational disturbances, and the idea of a long-orbiting object like Nibiru begins to feel less like pure invention and more like a theory that attempts to make sense of scattered evidence. In the modern era, astronomy has expanded our understanding of distant objects. We now know that the solar system contains many bodies on elongated orbits. Some take hundreds or thousands of years to return to the inner regions. Others may take tens of thousands. These discoveries show that long-period objects are not only possible but common. Many of these objects go undetected until they make their brief appearance near the inner planets, before fading back into the dark. So the notion of a large, distant body following an immense orbit is not inconsistent with what we now understand about celestial mechanics. If such a body exists, its influence on Earth would depend on many factors: the distance of its closest approach, its mass, its speed, the gravitational interactions it might induce on smaller bodies. Even without a direct encounter, a passing world could disturb the Oort cloud, sending comets inward over long timescales. These comets could then impact Earth centuries or millennia later, or they could fragment into showers that bombard the atmosphere. Over time, these events might leave geological signatures that appear as sudden spikes in devastation. And ancient cultures, observing the aftermath, might have interpreted these disruptions as acts of gods, cosmic battles, or signs of celestial visitors. There is also the matter of how civilizations rebuild after such events. Many ancient sites show evidence of sudden abandonment, followed by periods of reconstruction using different styles or materials. Settlements vanish, only to reappear in modified forms centuries later. In some cases, Entire cultures seem to have relocated after destructive episodes that affected vast regions. These shifts align with layers of geological disturbance, soot deposits, sudden cooling periods, or massive flooding. The stories preserved in these cultures often describe these periods as times when the world changed dramatically, sometimes overnight. The idea that such changes could be tied to a distant planet's return is not proven, but it serves as a lens through which we can explore why ancient people might have felt the need to record these events with such urgency. They may not have understood orbital mechanics or cometary dynamics, but they recognized patterns in the sky and in the land. They track the movement of stars, the rhythms of seasons, and the slow shifts in celestial alignments. Some cultures built structures aligned with precise astronomical markers, suggesting a long-standing focus on cycles in the heavens. If they noticed periodic changes in the environment that aligned with these cycles, even loosely, it would have reinforced the belief that the sky and the earth were connected through forces beyond human control. As we move deeper into this exploration, we'll consider how ancient accounts, geological records, and astronomical possibilities intersect to form a picture of a world shaped by repeating influences, not as a definitive answer, but as a way of weaving together the fragments left behind by civilizations that endured more than one era of upheaval. And though these ideas are often met with skepticism, they offer a perspective through which scattered evidence begins to feel connected, forming a mosaic of events that suggest a larger rhythm. The idea that a distant planet might be part of this rhythm does not require believing in myths as literal history. It simply invites us to consider how ancient peoples encoded their understanding of the world, how they preserved memories, and how they tried to make sense of forces that arrived without warning. As we continue through this story, we will follow the threads of these memories, tracing them through time, observing how they shift from culture to culture, and noticing how they often point back to events that felt cyclical rather than random. And so, with the night settling in and the mind softening into quieter thoughts, we move forward into this exploration of cycles, catastrophes, and the possibility that Earth's past might hold signs of recurring influences from beyond the familiar boundaries of our sky, allowing this idea to unfold gently as we continue into the next part. Long before any civilization learned to write the names of its rivers or mark the borders of its kingdoms, there were moments when entire communities paused and turned their attention skyward. These were not casual glances or idle curiosities. They were reactions shaped by events that felt larger than anything human hands could influence. Events that pressed themselves into memory long before clay tablets, long before monuments, long before anyone could store a single idea in ink or stone. The earliest people lived with an unbroken awareness of the land and the heavens, and when the world suddenly shifted in ways they could not explain, their first instinct was to look upward, because the sky seemed like the only place where such enormous disturbances could begin. Across continents, early societies encountered natural events that arrived with an intensity capable of reshaping coastlines, altering climates, and changing the course of their lives overnight. As these people watched storms that tore apart forests, fires that burned across dry seasons, or rivers that rose with sudden force, they often felt that these events were not isolated or random. Something deeper seemed to guide them. Waves that reached further than any previous storm, winds that carried strange warmth or unexpected cold, ash that settled in layers thick enough to alter agriculture, entire herds of animals moving across plains as if responding to threats humans could not yet detect. These were the kinds of signals that early humans tried to interpret so they could understand their place in a world far larger than their communities. When we read the oldest surviving accounts, even those written thousands of years after many of these early events, we find descriptions that carry a sense of inherited memory. Some stories speak of waters that rose without warning, carrying entire villages away. Some tell of seasons that stopped behaving as expected, arriving too early or too late. Others describe skies that darkened for extended periods, turning days into muted twilight. These stories did not arise in isolation. Communities repeated them for generations because they encoded lessons and reminders about forces that had once come through with such magnitude that forgetting them felt dangerous. And though these stories often became wrapped in mythological imagery, the central impressions remained grounded in lived experience. In later centuries, when civilizations began to document their histories with more structure, these same themes appeared with greater detail. The earliest recorded flood narratives, for example, come from regions where river systems were vital to life. These rivers sometimes behaved with predictable seasonal patterns, but occasionally they surged far beyond their usual limits. Archaeologists have found sediment layers indicating sudden inundation events that reshaped entire floodplains. These layers show abrupt transitions from settled soil to deep deposits of silt and clay, suggesting periods when water arrived with force beyond human preparation. These events left long-lasting marks not only in the earth, but in the collective understanding of the people who live nearby. What makes these stories even more intriguing is how similar they are across regions that had no direct contact with each other. Cultures separated by oceans produce narratives that describe vast waters covering familiar landscapes. Islands recount periods when the sea rose higher than the tallest palms. Mountain communities preserve tales of torrents that reached valleys long considered safe. Inland groups speak of rain that fell for durations far surpassing typical storms. These accounts do not match perfectly, but they show a shared recognition of events severe enough to disrupt life on a scale that demanded explanation. As these early peoples looked outward, they tried to connect these events to the movements in the sky. Many ancient structures were oriented towards celestial markers, suggesting that watching the heavens had practical importance. Alignments with solstices, equinoxes, and prominent stars helped them track seasons and prepare for planting or harvesting. But some alignments seem aimed at cycles or appearances that do not correspond to regular seasonal patterns. This implies that certain events, possibly rare or irregular, made such lasting impressions that communities built physical markers to ensure future generations would remember them. These markers served as warnings, records, or reminders that the world might not always behave gently. In regions where writing later emerged, tablets and inscriptions describe upheavals that arrived with suddenness. Texts from early Mesopotamia speak of years when rivers overflowed far beyond their banks, when storms raged through entire seasons, or when the sun seemed distant behind the layers of haze. Similar descriptions appear in ancient Chinese records, in Andean traditions, and in the early literature of India. Each region developed its own explanations, but the core events share striking similarities. Large-scale flooding, unexpected cold periods, intense droughts, and earth-shaking disturbances all appear in cycles that early observers tried to understand. Some researchers propose that these events could have been linked to a range of natural causes, including volcanic eruptions, shifting climate patterns, or impacts from celestial objects. Each of these possibilities has evidence supporting it. Volcanic eruptions have triggered global cooling and widespread darkness. Sudden climate shifts altered rainfall patterns and caused rivers to swell beyond their usual limits. Impacts from comets or meteorites scattered debris into the atmosphere and affected ecosystems for years. These events leave geological traces that scientists can analyze. But the idea that these events might also follow broader, slower cycles opens another avenue of interpretation. The concept of a returning external influence, something with an immense orbit that occasionally interacts with the solar system in ways that produce bursts of activity, brings another layer to this exploration. If a distant object disturbed cometary reservoirs or influenced the orbits of smaller bodies, it could create periods when Earth faced increased risks from impacts or from atmospheric changes caused by dust and debris entering the upper layers of air. Early civilizations, lacking modern instruments, would have interpreted such changes through the lens of observable natural patterns. They might have seen the sky brighten with unusual objects, noticed shifts in star positions, or experienced unusual red or dim glows at dawn and dusk. Over time, this would lead to stories describing celestial disturbances that coincided with catastrophic events. Many flood narratives begin not with rainfall but with changes in the sky. Some describe an unusual light or a long-lasting glow preceding the water's rise. Others mention thunder-like sounds unrelated to storms. Some speak of fire or smoke in the heavens before the onset of long rain. These details are often overlooked when focusing only on the flood itself, yet they may hint at atmospheric disturbances that occurred before the main catastrophe. Volcanic eruptions provide one explanation, but if these accounts reflect events occurring across wide regions and different eras, other influences might also be relevant. In coastal regions, ancient settlements show layers of marine sand deposited far inland, suggesting waves far larger than typical storms. These layers are sometimes found alongside evidence of fire or debris that cannot be explained by simple flooding. This mixture of water, sediment, and burnt material indicates complex events involving both atmospheric and oceanic disturbances. Tsunamis, impacts, and rapid climate shifts can all produce such combinations. If these events happened in clusters, separated by long intervals, they would create a pattern that ancient observers might later interpret as cyclical. In addition to floods, stories of fire descending from the sky appear across many early cultures. These accounts describe streaks of light, prolonged illumination at night, or showers of glowing material that fell across broad regions. Modern science recognizes these descriptions as consistent with meteor storms, comet fragments entering the atmosphere, or even airbursts from objects that explode before reaching the ground. These events could ignite forests, vaporize water sources, or trigger further disturbances in the climate. Communities that witnessed these events would have been deeply affected, shaping their collective understanding of the world in ways that persisted for generations. As these communities tried to rebuild after such events, they carried forward the lessons embedded in these experiences. They developed rituals, calendars, and structures that reflected an attempt to anticipate or interpret future disturbances. In regions where agriculture depended on stable conditions, sudden disruptions forced new strategies. Some groups migrated to higher ground. Others altered their farming methods. Some developed complex irrigation systems to manage unpredictable water levels. These adaptations show how societies responded to patterns that felt familiar, even if they occurred far apart in time. The earliest written flood narratives, such as the Sumerian story of a great deluge or the later Akkadian account embedded within the Epic of Gilgamesh, do not describe simple local flooding. They depict waters rising to such heights that entire civilizations vanished beneath them. Archaeological evidence indicates that Mesopotamia did experience major flooding events, some of which covered vast areas. But the scale described in these early stories suggests that the memory preserved may extend beyond a single event. These narratives might combine the details of several large floods or reflect a tradition rooted in memories carried from even earlier times. Similar patterns appear in stories from faraway regions. In South America, traditions describe floods that swept across valleys and up mountain slopes. In the Indo-Pacific, island cultures preserve tales of rising seas that forced families to flee to higher islands or mainland regions. In North America, indigenous traditions recount long periods when the land was reshaped by water, moving with extraordinary force. These stories often contain practical details about where to seek shelter, how to recognize early signs of rising water, or where to rebuild after the event. These practical elements suggest that the stories served not only as mythic narratives, but also as cultural memory tools meant to guide future generations. When civilizations develop such stories, they usually reflect experiences significant enough to shape the entire identity of a community. A single storm or minor flood rarely leaves such deep impressions. Events that transform landscapes alter coastlines, or impact food sources for generations leave marks strong enough to transcend the immediate aftermath. They become part of how societies define themselves. They become symbols of resilience, renewal, or divine engagement. They become stories that instruct people on how to endure future challenges. If certain catastrophes were linked to larger cycles, early civilizations may have sensed patterns even without the tools to identify exact intervals. They may have noticed that certain signs appeared in the sky before disruptions on the ground, unusual alignments, changes in star positions, long-lasting glows or dimness, unfamiliar objects moving across the horizon. These observations could have encouraged communities to look upward with concern when similar signs appeared centuries later. Over time, such awareness could shape cultural attitudes towards celestial events, turning astronomical observation into not only a scholarly pursuit but a matter of survival. This is part of what makes the idea of a distant object influencing Earth so intriguing. Not because it provides a simple explanation, but because it offers a framework for understanding why ancient peoples connected the sky with events on the ground. They lived in a world where environmental stability was never guaranteed. They depended on the sky for agriculture, navigation, and timing. When disruptions occurred, the sky seemed like the most logical place to seek meaning. If early observers noticed cycles, even vaguely, they would have recorded them in the only language available to them. Over generations, stories evolve, details change, images shift, names transform, but core memories persist. A flood that once swept across a valley becomes a flood that covered the world. Fire that once fell in a narrow region becomes fire that reshaped the sky. Darkness that once lasted months becomes darkness that lasted years. These expanding metaphors do not erase the original events. They amplify them, ensuring that future listeners would not forget the lessons carried within them. This is why the earlier stories about floods, fires, or upheavals hold such importance when considering the broader idea of cyclical catastrophes. They reveal how deeply ancient communities felt the impact of these events. They demonstrate that early humans did not passively accept these changes. They tried to understand them. They tried to prepare for them. They tried to preserve the memory of them in forms that could survive long after the immediate witnesses were gone. And so, as we move from these first recorded impressions of upheaval into the broader exploration of what might have caused them, we continue along a path that ancient peoples began long before anyone could calculate orbital mechanics or identify distant celestial bodies. Their stories provide the earliest framework through which we can consider how civilizations interpreted recurring disturbances, offering us a starting point as we follow these threads further into the long arc of history and the patterns that might lie within it. As soon as ancient stories begin describing upheavals that seem to arrive in intervals too wide for any ordinary seasonal cycle, another theme starts to take shape. These narratives often imply that something beyond the familiar planets might be moving along a path that eludes regular observation. This possibility appears in fragments scattered across myths, cosmologies, and astronomical traditions. No single account lays out a coherent model. Instead, faint impressions appear again and again. The idea of an object that drifts for ages beyond visibility before returning unpredictably. Something that does not follow the steady circular paths of the planets, known to early observers. Something that seems to slip between the edges of knowledge, leaving only indirect signs of its passage. As astronomy developed, early civilizations created maps of the heavens that tracked movements with surprising accuracy. Their records show an impressive understanding of planetary cycles, star risings, and seasonal indicators. These cultures observed regular planetary loops and predictable retrograde motions. They understood that some bodies moved on faster paths close to the sun, while others traced wider arcs that took far longer to complete. These were manageable systems, stable enough that entire agricultural calendars and ritual cycles were built upon them. Yet even within these highly structured systems, hints of irregularity appeared. Some ancient astronomers recorded disturbances in star positions. Others noted bright objects that lingered longer than typical comets. A few left behind descriptions of unusual movements that did not match any known celestial patterns. When examining these accounts alongside geological and climatic data pointing to recurring episodes of upheaval, a possibility emerges that draws researchers and storytellers alike. It is the idea of a long-orbiting body far beyond the known planets, following a path so stretched and distant that it only approaches the inner solar system after immense spans of time. This object would complete one circuit not in years or centuries, but in millennia. Such an orbit would place it out of reach of regular observation by ancient skywatchers, who relied on naked-eye viewing and long-term generational knowledge. Modern astronomy has shown that extremely long orbits are not only possible, but well attested in the outer reaches of the solar system. Many distant objects inhabit the Kuiper Belt and beyond. Some follow paths that take thousands of years to complete. Others move so slowly at the far edge of the sun's influence that they appear almost stationary across human lifetimes. If an object of significant size followed an elongated path that carried it deep into these regions, early civilizations would have had no chance of tracking it across its full journey. They would only witness brief portions of its route, assuming it came close enough to be visible at all. The long orbit concept gains even more shape when considering how gravity behaves on the far outskirts of the solar system. Objects in those regions are influenced not only by the Sun, but also by passing stars, the galactic tide, and interactions with the cloud of icy bodies extending trillions of miles from the centre. These forces can stretch or tilt orbits over time, creating paths that seem improbable from the perspective of the inner planets. A body could travel an arc that barely skirts the Sun before returning to the distant dark for epochs. If this path intersects regions dense with small icy objects, its passage could disturb them, sending some inward on new trajectories. These disruptions could create cascades of material moving toward the inner planets, long after the original body has vanished from view. The idea of an object with a long orbit is not intended to claim that myths were literal descriptions of distant astrophysical bodies. Rather, it provides a framework for understanding why so many ancient traditions speak of returning forces, cycles of destruction, and celestial disturbances that do not match familiar planetary behaviour. A distant object on a stretched orbit provides a natural mechanism for generating irregular but powerful events that could align with some of the patterns recorded in geological and archaeological data. Ancient cultures did not need to see the object directly. They only needed to observe its effects. Some ancient records describe periods when the sky appeared more active, with increased sightings of blazing objects moving across the horizon. These accounts often appear shortly before stories of environmental disruption or societal change. Modern science recognizes that unusual sky activity can produce real consequences on Earth. Increased meteor storms, for example, can deposit large amounts of material into the atmosphere, affecting climate. Larger impacts can trigger dramatic shifts in temperature or disrupt ecosystems. Even without impacts, increased cometary activity can introduce significant dust into the upper atmosphere. This dust can affect sunlight reaching the surface, altering growing seasons and temperature patterns. If a distant body disturbed reservoirs of icy or rocky debris as it moved through its orbit, such events could become more frequent for a period of time. Early civilizations observing these changes would interpret them through the lens of the patterns they knew. They might associate them with cosmic cycles, divine interventions, or returning celestial beings. Over generations, these interpretations would shift, but the impression of something that returns after long intervals would persist. This persistent impression appears across multiple mythic traditions. Some describe ages of the world separated by upheavals. Others describe cyclical destruction followed by renewal. Some speak of a celestial object or being that departs after an event and is expected to return. While the imagery varies, the underlying structure often follows a pattern that resembles a long cycle rather than a sudden isolated occurrence. These stories were not created to describe orbital mechanics. They emerged from attempts to understand why the world seemed to change dramatically at intervals longer than any human life. As astronomy advanced, many of the simpler explanations for celestial change gave way to more systematic observations. Civilizations with established astronomical traditions built observatories, created detailed star charts, and developed mathematical frameworks to predict planetary motions. Yet even then, certain irregularities persisted. Early astronomers recorded unusual long-term changes in the positions of distant stars. These changes were subtle and could indicate many things, including parallax, precession, or observational limitations. However, they also left open the possibility of gravitational influences from unseen bodies. Modern astronomy continues to explore this possibility. In recent years, observations of objects in the outer solar system have revealed unusual clustering in their orbits. Several bodies follow similar trajectories that are difficult to explain without assuming the presence of a larger, more distant object exerting gravitational influence. This hypothetical object, often referred to as a yet unobserved planet, follows a path so elongated and distant that it has avoided detection with current instruments. Simulations suggest that if it exists, its orbit could take thousands of years to complete. Such an orbit aligns conceptually with the kind of cycles described in ancient narratives that emphasize long intervals between disturbances. When considering how ancient peoples might have interpreted events influenced by such a body, it is important to recognize that they viewed the world through a frame that connected the heavens and the earth. They did not separate celestial events from terrestrial consequences. They saw storms, floods, droughts, and earthquakes as part of a larger system influenced by forces beyond immediate reach. The sky served as their indicator of upcoming changes. If they observed unusual celestial patterns followed by environmental shifts, they would incorporate these observations into their understanding of the world. This connection between sky and land appears consistently in early records. Many ancient calendars and ritual cycles are tied to astronomical markers, not only for agricultural purposes but also for anticipating changes that might bring danger. Some civilizations maintained long-standing traditions warning of periods when the world would be unsettled. These traditions often appear alongside stories of stars moving in unfamiliar ways, or the arrival of bright celestial visitors. These elements reflect observations tied to cycles longer than individual lifetimes. The persistence of these themes through centuries suggests that early peoples observed patterns even if they lacked the means to measure them precisely. Oral traditions often preserved these patterns by embedding them in stories with strong emotional resonance. Tales of returning cycles, disruptive events, and celestial forces carried forward the memory of earlier catastrophes. Even after the details faded, the structure of the story endured. This structure rests on the idea of recurrence, which aligns naturally with the concept of a long-orbiting object. Long orbits create intervals that exceed human generational memory, making them difficult to track directly. Instead, societies would experience only the effects. These effects might include increased comet activity, changes in climate, or disruptions in ecosystems. If these events occurred over several generations, the memory of earlier impacts would be filtered through stories, transforming them into cautionary narratives. These stories would warn future communities to remain aware of signs in the sky that might indicate an approaching disruption. The idea of a long orbit challenges the simple expectation that planets should follow paths near the ecliptic and complete cycles measurable within human lifetimes. Traditional planetary models favour nearly circular orbits for bodies within the inner solar system. But beyond these regions, gravitational forces and orbital dynamics create more complex possibilities. Bodies influenced by distant interactions can follow stretched or inclined paths that defy the patterns familiar to ancient observers. These bodies would not behave like stars or known planets. Their movements would be slow, subtle, and difficult to track, making them appear only briefly before fading once again. This fleeting appearance aligns with mythic descriptions of celestial visitors that emerge in the sky for short periods before vanishing without trace. These visitors are often associated with significant events that change the course of societies. Stories describing these appearances often carry tones of awe, fear, and reverence. They do not necessarily focus on the object itself, but on the consequences that follow its arrival. These consequences may reflect real environmental changes triggered by cosmic influences that ancient people could not fully explain. A long orbit also provides a natural structure for patterns found in climate and geological records. Evidence exists of periodic spikes in comet activity, abrupt climate shifts, and layers of impact debris that appear at intervals far longer than human historical timelines. These intervals are not perfectly regular, but they cluster in ranges that could reflect cycles influenced by external gravitational forces. If a distant object periodically disturbs regions rich in icy bodies, the resulting cascade of material could reach Earth long after the object itself has receded. This delay would create cycles of disturbance that do not match the object's immediate presence in the inner solar system. When ancient communities experienced disruptions that seem connected to previous tales, they interpreted these events through the framework available to them. Stories that spoke of returning forces would gain renewed relevance. Communities would revisit old warnings, reshape rituals, and adjust their calendars in response. These responses show that the idea of recurrence remained deeply rooted even when people lacked precise measurements. The persistence of similar themes across distant cultures indicates that these ideas emerged from repeated experiences rather than isolated imagination. As knowledge grew and civilizations became more interconnected, some stories evolved to describe these cycles with greater detail. Scholars, priests, and astronomers attempted to systematize observations. They tracked unusual celestial events, recorded their occurrences, and correlated them with environmental changes. These records show that ancient people recognized patterns even if they did not understand their origin. Over time, these observations contributed to the belief that celestial forces governed long-term cycles of calm and upheaval. This belief does not require literal interpretations of myths. It instead highlights the human desire to find continuity in events that appear sudden or overwhelming. A long-orbiting object provides a plausible framework for understanding why ancient cultures produce stories with similar structures, even when separated by geography and time. These stories reflect efforts to understand large-scale changes within the constraints of early knowledge. Long orbits challenge modern intuition but align with the dynamic and complex nature of the solar system's outer regions. They offer a way to connect geological, climatic, and mythic patterns without relying on improbable speculation. They provide a structure through which we can consider how distant forces may have influenced Earth in ways subtle at times and dramatic at others. As we continue to explore these possibilities, the idea of a long orbit becomes less about identifying a specific planet and more about understanding how ancient minds interpreted changes in their world. Their stories become guideposts, pointing toward patterns that may carry traces of distant influences. These influences form the next step in following the threads woven between the sky, the Earth, and the memories preserved by civilizations that lived through cycles far larger than themselves, allowing the path ahead to unfold naturally as we continue. As the idea of a distant world drifting along an immense arc begins to take shape, the natural next step is to consider what such a world could actually do during its closest approach. Ancient stories often describe moments when the sky seemed to behave in ways that no ordinary storm or seasonal cycle could explain. These stories speak of altered sunlight, shifting winds, long-lasting disturbances, and sudden changes in climate that transformed landscapes within a few generations. They also refer to movements in the heavens that left observers unsettled, as if the familiar motions of stars and planets had been thrown into slight disarray. Whether these impressions reflect direct encounters or only the aftermath of distant influences, They suggest that early civilizations sensed something larger than local weather patterns. In the modern era, we understand that celestial bodies interact through gravity. Every object, no matter how distant, exerts a pull on every other. Normally these forces are too subtle to produce noticeable effects on Earth. The planets in our system follow stable orbits, separated by vast distances that prevent major disturbances. But if an object with significant mass travelled far outside these familiar paths and then drifted inward, its gravitational influence could alter conditions in ways unpredictable to early observers. These alterations would not always appear dramatic at first. Some might unfold slowly, building over decades until they reached a tipping point that produced sudden consequences. Ancient people would not have understood these forces, but they would have felt their effects in the world around them. They would have noticed changes in ocean patterns, shifts in temperature, or disruptions in animal migrations. They would have observed subtle changes in star positions or the behaviour of celestial events that no longer matched older records. These shifts could create the impression of a sky that had tilted or realigned, producing a sense that the universe itself had altered course. The Earth is not rigid. Its crust is divided into plates that move slowly over time. Its oceans respond to gravitational forces from the Moon and the Sun. Its atmosphere circulates according to temperature gradients shaped by solar energy. Even small changes in these forces can produce outsized effects. If a large object passed close enough to Earth to influence these systems, even without direct contact, the result could be a period of instability. Not a world-ending collision, but a temporary disruption that reshapes climates, redistributes water, or shifts the timing of seasons. These kinds of disturbances appear throughout the geological record. Layers of sediment show sudden transitions from lush conditions to arid ones. Cores drilled from ice sheets show spikes in temperature changes occurring far faster than normal. Fossil distributions reveal abrupt shifts in ecosystems over short periods. These patterns appear in cycles that have puzzled scientists for decades. Some cycles can be explained by Earth's orbital variations, known as Milankovitch cycles. These include changes in Earth's eccentricity, axial tilt, and wobble. These internal cycles influence climate over tens or hundreds of thousands of years. But other cycles appear irregular, occurring at intervals that do not align neatly with these known patterns. The idea of a passing world influencing Earth's tilt or orbit offers another layer of interpretation. If a distant object approached the inner solar system along a long stretched path, its gravitational influence could alter Earth's axial tilt slightly. Even a small change in that tilt would shift how sunlight reaches the surface, affecting climate zones. Regions that were once temperate could become colder. Others might warm. Monsoon patterns could intensify or weaken. Ice sheets could expand or retreat. These shifts would not necessarily be catastrophic in a single moment, but they could trigger slow-moving environmental changes that eventually lead to widespread upheaval. Ancient cultures often described periods when the seasons no longer behaved as expected. They referred to winters that lasted longer than usual, or summers that arrived later than normal. They described harvest cycles thrown into confusion. They spoke of droughts that persisted beyond memory, or floods that repeated with unnatural frequency. These experiences would have felt overwhelming to people who depended entirely on the land for survival. Without understanding the underlying causes, they would turn to the sky for meaning, interpreting these events as signs of cosmic imbalance. Some traditions describe the sky itself appearing to shift. They mention constellations rising in unfamiliar positions, or the sun appearing lower or higher on the horizon than in previous generations. Today we know that precession, the slow wobble of Earth's axis, causes long-term shifts in star positions. But ancient descriptions sometimes include sudden changes that do not align with the slow pace of natural precession. These accounts might reflect temporary conditions created by atmospheric disturbances or unusual light scattering. They might also reflect altered climate patterns affecting visibility. But they could also hint at the possibility that ancient observers witnessed real shifts in Earth's orientation, subtle enough to avoid global chaos, yet noticeable enough for attentive sky watchers. Gravity can influence more than just tilt. If a large object passed close enough, it could cause small perturbations in Earth's orbit. These perturbations would alter the distance from the Sun, changing the amount of solar energy reaching the surface. Even minor variations can create significant climatic effects when sustained over centuries. Ancient people would experience these changes as long-term weather instability. They would not see the cause, but would live through the consequences. Ocean behaviour also responds strongly to gravitational forces. The Moon creates tides by pulling on Earth's water. A passing world with substantial mass could create temporary changes in ocean levels, amplifying high tides or shifting water distribution in certain regions. These changes would not need to be enormous to cause widespread flooding, especially in early river valley civilizations that relied on predictable water cycles. Sudden surges in river levels could wipe out settlements, alter coastlines, and force migrations. The memory of these events would endure long after the physical traces faded. This idea aligns with stories from many cultures describing times when the oceans rose unexpectedly. These stories often speak of water arriving without a clear cause, as if the seas themselves had moved. Some traditions describe waves that travelled inland far beyond normal boundaries. Others speak of entire coastlines disappearing. These accounts may reflect tsunamis triggered by earthquakes or underwater landslides, but they could also reflect periods of sudden tidal amplification influenced by external gravitational forces. Evidence for ancient shoreline changes supports the possibility of sudden shifts. In several regions, archaeologists have found ancient settlements located far inland from modern coastlines, yet built near what was once the sea. Other sites lie underwater, still showing traces of human activity. These changes reflect rising and falling sea levels influenced by both climate and tectonics. But if some changes occurred during periods associated with increased environmental disturbance, they may reflect more complex interactions. Another mechanism through which a passing world could influence Earth involves magnetic fields. Earth generates a magnetic field through the movement of molten material in its core. This field protects the planet from solar radiation and influences atmospheric conditions. Disturbances in this field can alter climate patterns, shift auroral activity, and even affect animal migrations. If a large external body with its own magnetic influence passed nearby, it could create temporary disturbances in Earth's magnetic field. These disturbances might be mild but still noticeable. Ancient observers might interpret unusual lights in the sky, altered aurora patterns, or changes in animal behaviour as signs of cosmic unrest. Archaeomagnetic studies reveal periods when Earth's magnetic field weakened or shifted rapidly. These changes coincide with environmental instability in some regions. Although many mechanisms can influence the magnetic field, the possibility of external influences cannot be dismissed. Ancient stories describing the sky glowing in unusual colours or the air feeling charged could reflect these magnetic changes. The concept of the sky tilting does not require a literal rotation of the heavens. It can reflect any event that alters the perceived stability of the world. Climate shifts, ocean surges, altered winds, or disturbed star positions could create the impression of a universe no longer aligned with familiar patterns. Ancient people relied heavily on these patterns for navigation, agriculture, and ritual timing. When these patterns broke down, the sense of security they provided collapsed as well. The memory of such disruptions appears in stories of reordered heavens or cycles of renewal after cosmic imbalance. These stories do not need to align perfectly with scientific explanations to carry a core truth. They reflect the experience of living through changes that felt larger than any earthly cause. One of the most compelling aspects of ancient accounts is how often they describe long periods of darkness or dim light preceding major environmental changes. These descriptions can reflect volcanic eruptions that fill the atmosphere with ash. They can also reflect large fires, dust storms, or impact events. but they might also reflect periods when increased comet activity introduced dust into the upper atmosphere, blocking sunlight, if such activity was triggered by disturbances from a distant object. People living through the dimming would interpret it as a sign that the sky itself had shifted. The Earth's climate system is sensitive to changes in sunlight. Even slight reductions in solar radiation can cool regions significantly. Ancient descriptions of extended cold periods or failing crops could reflect these mechanisms. The idea of a world passing close enough to trigger such changes becomes more plausible when considering how small disturbances can cascade into larger effects. When ancient civilizations rebuilt after such disruptions, they often changed their cultural practices. They developed new calendars, introduced new rituals, or redefined their cosmologies. These changes reflect a recognition that the world had entered a different phase. They may also reflect an attempt to align human behavior with new patterns in the environment. By adjusting their understanding of the heavens, they adjusted their expectations for the land. Some ancient structures seem designed to track celestial alignments that shift over long periods. These alignments could have served as early warning systems, helping people notice changes in the sky that preceded environmental instability. Even without knowledge of orbital mechanics, early observers understood that the heavens offered insight into the world's behaviour. The idea of a passing world altering Earth's conditions does not require dramatic singular events. It allows for cumulative influences that unfold over centuries. Ancient people would recognise the outcomes but not the cause. They would see a world that no longer behaved as expected and interpret the change through the frameworks available to them. Their stories would reflect these interpretations, carrying forward memories of a sky that once tilled or dimmed or filled with unusual lights. These memories, preserved across generations, would become part of the broader narrative of cycles and disturbances that shaped early civilizations. As we continue through this exploration, the next part begins to focus on how these cycles of fire, water, wind and ice appear in ancient accounts and geological records, and how they create the impression of a world influenced by powerful yet intermittent forces, allowing the narrative to move forward without pause. As we turn from the idea of a passing world to the ways its influence might manifest, the pattern of ancient catastrophes becomes the next piece of the puzzle. Early civilizations did not record isolated disasters as unrelated events. They tended to frame them as part of a repeating cycle, something that returned after long intervals, altering the land, reshaping coastlines, and forcing communities to adapt. These cycles often carried themes of fire and water, floods that erased entire regions, fires that consumed forests and fields, periods of extreme cold following periods of intense heat. To the people living through these episodes, the world seemed to move between phases of abundance and destruction with a rhythm too deliberate to ignore. Modern researchers examining geological and climatic data have also noticed patterns. Deep ice cores reveal layers of volcanic ash scattered through time at recurring intervals. Sediment layers show signs of flooding that appear across continents and clusters. Tree rings record periods of rapid cooling followed by long recoveries. Fossil beds reveal sudden transitions in ecosystems that do not align with slow, natural evolution. These changes often occur at intervals long enough that human societies would struggle to track them, yet they are short enough to leave lasting impressions. When placed beside ancient stories, these scientific records create a mosaic of cycles involving dramatic shifts in fire and water. One of the most recognizable cycles in ancient accounts is the Great Flood narrative. Versions appear in Mesopotamia, China, Central America, the Pacific Islands, South America, and many other regions. Some describe a global inundation. Others describe regional floods so large that they felt like the end of the world. Archaeology supports the presence of huge flood events in multiple locations. River valleys show layers of sediment deposited suddenly. Coastal regions reveal ancient settlements buried under marine sand. Inland basins contain freshwater species mixed with marine deposits. These events did not all occur at the same time, but they occur in clusters separated by long intervals. Fire cycles carry their own patterns. Ancient stories describe fire descending from the sky, fire sweeping across landscapes, and fire marking the end of one age and the beginning of another. Geology reveals layers of soot within ice cores indicating large-scale combustion events. Some layers align with volcanic eruptions. Others align with impact events or widespread wildfires triggered by atmospheric disturbances. These fire layers appear in repeated intervals, suggesting that Earth undergoes periods when conditions favour ignition on massive scales. Between fire and water are the cycles of climate change that shape ecosystems. Sudden warming events appear throughout the paleoclimate record. These are often followed by sharp cooling periods triggered by ash, dust, or changes in ocean circulation. Ancient people would have experienced these shifts not as abstract climate changes, but as disruptions in crops, migrations of animals, and changing seasonal patterns. These disruptions could devastate food supplies, force migrations, or lead to conflicts over resources. Their stories reflect the emotional weight of these experiences. They describe lands turning barren, forests dying back, or rivers drying out, followed by periods of renewal once conditions stabilized. The idea that these cycles repeat suggests the possibility of a trigger that operates beyond the immediate control of Earth's internal processes. Volcanoes erupt unpredictably. Storm systems vary by region. Tectonic activity does not follow fixed schedules. Yet the broader cycles of catastrophe seem to arrive with a loose structure that hints at influences from beyond Earth. One candidate is the gravitational interaction of a distant object disturbing smaller bodies in the outer solar system. These disturbances could send comets inward at intervals that correspond to geological layers showing evidence of impacts or atmospheric dust. Evidence from the fossil record supports the idea of increased comet activity at certain times. Some extinction events coincide with spikes in iridium, a metal common in comets but rare on Earth's surface. Other events coincide with layers of microtectites, materials formed when impacts melt and eject rock. These layers appear in clusters separated by tens of thousands of years. While not perfectly regular, they follow patterns consistent with disturbances from a repeating influence. If a distant world periodically passed near regions of the solar system, dense with cometary material, its gravitational pull could disturb those regions enough to send debris toward the inner planets. Water cycles from ancient accounts often follow fire cycles. A large atmospheric disturbance caused by dust or ash could disrupt rainfall patterns, causing years of drought followed by years of heavy precipitation. When ancient stories describe long dry periods preceding devastating floods, this sequence reflects real climate patterns observed after major volcanic eruptions or impact events. Dust in the atmosphere reduces sunlight, cooling the surface and altering evaporation. Once the dust settles, ocean temperatures warm unevenly, shifting storm patterns and producing intense rainfall. These natural mechanisms create the impression of cycles when they occur after disturbances that themselves follow broader intervals. Throughout ancient histories, some cultures developed calendars and timekeeping systems that tracked these cycles. The Maya long count calendar records long intervals that some researchers believe may be linked to environmental cycles. Chinese records track sequences of natural disasters alongside astronomical observations. Mesopotamian texts include references to repeating ages, each marked by a catastrophic event. These records were not scientific in the modern sense, but they show that early societies recognized patterns and attempted to preserve them for future generations. Patterns involving fire also appear in traditions describing celestial objects associated with destruction. Stars that grew brighter, trails of light, extended displays of glowing material. These descriptions match modern observations of comet outbursts or meteor storms. Comets can shed material as they approach the sun, leaving trails that Earth passes through at regular intervals. These intervals become meteor showers in modern calendars. But if a larger comet fragmented, its debris could create meteor storms intense enough to ignite fires, deposit dust, or alter atmospheric composition. Ancient observers witnessing such events would experience them as near-apocalyptic displays. If long-orbiting disturbances triggered periods of increased comet activity, the resulting cycles of fire and water would appear coordinated. First, the sky would grow active with streaks of light as Earth passed through debris fields. Then, small impacts or atmospheric disturbances would ignite fires across dry landscapes. Afterward, dust from fires or impacts would cool the atmosphere. This cooling could disrupt seasonal rains, first reducing precipitation and then triggering floods once normal patterns resumed. Civilizations dependent on stable conditions would struggle through each phase, leaving behind stories of fire preceding water, destruction preceding renewal. Some traditions describe ages defined by elements: an age of fire, an age of water, an age of wind, an age of earth. These elemental ages align metaphorically with geological phases marked by fire from volcanic or atmospheric upheaval, water from floods, wind from climate shifts, and earth from tectonic or landscape changes. These symbolic frameworks reflect real experiences transformed into cultural narratives. By framing repeated catastrophes as cycles governed by larger forces, ancient people made sense of a world that repeatedly shifted under their feet. Scientists studying sediment layers have noticed cycles of wildfires aligning with cycles of flooding. Charcoal layers appear just below thick layers of sediment deposited by water. This pattern suggests that fires swept across landscapes shortly before floods arrived. These fires could be triggered by lightning, drought, or atmospheric heating. But in some cases, the charcoal layers appear alongside iridium or microtectite layers, indicating bombardment by small celestial debris. These correlations point toward a coupled fire and water cycles linked to external influences. Cycles also appear in ocean sediments. Layers show periods of high oxygen levels alternating with low oxygen periods. These shifts indicate changes in ocean circulation, which can be triggered by climate changes or influxes of fresh water from melting ice. These events often align with known disturbances, including volcanic eruptions, impacts, or abrupt warming periods. When these cycles repeat at intervals beyond the scale of human memory, ancient explanations reflect a belief in recurring ages rather than isolated events. Some modern researchers propose that Earth may pass through regions of heightened cosmic dust at long intervals. If so, increased dust could influence climate by reducing solar energy reaching the surface. Dust from comets disturbed by a distant object could create extended periods of dimming. Ancient accounts describing long nights, weakened sunlight, or seasons failing to arrive reflect these conditions. When dust settles, the rebound in solar heating could intensify storms, leading to flooding or rapid warming. These mechanisms create natural cycles that ancient observers would interpret as the world moving through phases: fire consuming forests or grasslands, water rising to reshape valleys, cold settling in unexpectedly, warmth returning with sudden intensity. These patterns would appear as if governed by a hidden timetable, prompting stories that assign meaning to each phase. Some traditions describe the world renewing itself after these cycles, land made fertile again after fires, soil enriched by flood deposits, ecosystems resetting after disruptions. These natural processes follow predictable patterns. Fire clears dense growth, allowing new plants to thrive. Floods deposit nutrient-rich sediment along riverbanks. Cooling periods eliminate certain species, allowing others to emerge. For ancient people, these renewals underscored the idea that destruction and creation were intertwined. If a distant world influenced these cycles indirectly, its long orbit could create the impression of a cosmic schedule governing both destruction and renewal. Early astronomers tracking rare celestial events might notice correlations between unusual displays in the sky and environmental changes. Even without precise measurements, they could sense that certain periods carried increased risk. This awareness shaped rituals, calendars, and stories designed to prepare communities for times of hardship. Modern technology has allowed scientists to compare climate patterns with astronomical cycles. Some cycles align with Earth's natural orbital variations. Others align with solar activity. A few align with patterns that remain unexplained. These unexplained cycles may reflect influences from the outer solar system. While no definitive link exists, the correlation between disturbances in comet reservoirs and certain geological events suggests a connection. The long memory of civilizations preserved these experiences in symbolic language. Fire descending before the waters rise. Water following years of heat. Winds growing fierce after long stillness. Each element representing a phase in a cycle that returned after long intervals. Ancient people encoded these cycles in myths, not because they understood orbital mechanics, but because they recognized patterns in the world around them. These cycles become most vivid when viewed through stories of lost cities, abandoned settlements, and regions transformed by sudden environmental change. Some cultures describe once thriving lands swallowed by water. Others tell of fields scorched until nothing grew. Some speak of forests reduced to barren plains. These transformations align with known geological events, yet they appear across many regions in ways that suggest global influences rather than isolated local disasters. As civilizations recovered from these cycles, they often developed new technologies or cultural practices. Irrigation expanded after floods. Controlled burns followed wildfires. New crops replace those lost to climate change. These adaptations reveal that ancient societies understood the need to adjust to changing conditions. Some even built structures designed to withstand future catastrophes, indicating long-term awareness of recurring disruptions. The recognition of cycles influenced philosophy and cosmology. Some traditions developed concepts of repeating ages of the world. These ages began with creation, moved through growth and decline, and ended in destruction before the next age began. These frameworks reflect both observation and imagination, blending environmental memory with symbolic meaning. They also hint at a deeper awareness that the world operates on long cycles beyond any individual lifespan. As we follow these threads, the idea of fire and water cycles arriving on schedule does not require a mechanical timetable. It reflects natural processes responding to disturbances that themselves might follow long intervals. If a distant object influences the solar system at irregular but recurring times, the resulting cascade of effects could produce cycles that feel rhythmic to observers living through them. These cycles continue to shape both the physical world and the stories that carry cultural memory. They reveal how ancient people interpreted their environment, how they preserved knowledge, and how they prepared for the return of forces that had shaped their past. This continuity guides us into the next part, where the ancient attempts to interpret these memories become an essential piece of understanding how myths, stories, and calendars preserve the traces of cycles that shaped the early world, allowing the path of the narrative to move forward without pause. Across the earlier civilizations, stories often carried a sense of urgency, as if they were not simply entertainment or spiritual teaching but attempts to preserve essential knowledge. These tales were spoken by elders, sung by travellers, carved into temple walls and woven into rituals that repeated generation after generation. They held details shaped by catastrophe, shaped by endurance, shaped by the need to remember something that could not be explained with the tools of early understanding. Myths often served as a cultural archive, storing the memory of events so vast and so devastating that they demanded long preservation. In this way, myths began behaving less like imaginative tales and more like encoded memories, passing information forward across centuries. Many societies believed that knowledge of past upheavals was something to be guarded. Some built entire education systems or priesthoods around preserving these memories. Others incorporated them into founding stories that shaped identity. The idea of cycles appeared frequently, along with the sense that great events had come before and would come again. These stories offered instructions, warnings, and explanations. Even if the original event was long forgotten, the memory persisted through symbols, metaphors, and narrative structures that endured. In Mesopotamia, one of the earliest literary civilizations, stories preserved on clay tablets describe destruction that arrived in patterns. The tale of a great deluge stands out, but beneath the surface of that one event lies a broader recognition of cycles. Kings were listed in long successions interrupted by natural disasters. Entire cities were described as rising, falling, and rising again, each time after a major disturbance. Between these disturbances, long eras of prosperity appeared. The stories blend theology, history, and astronomy, creating a system that feels like an effort to understand repeating upheavals. The scribes did not interpret their tales as mere fiction. They saw them as vital records of a world that had changed many times. In India, ancient texts describe cycles of creation, preservation, and dissolution, each lasting immense spans of time. These cycles are framed as cosmic processes, far larger than human experience. Yet when looked at through the lens of natural memory, they resemble attempts to describe repeating phases of destruction and renewal. Detailed accounts describe fire, floods, darkness, and changes in the sun's behaviour. These descriptions align with geological evidence of climatic changes and catastrophes experienced in the region across long intervals. While framed in spiritual terms, the underlying structure reflects memory reinforced through ritual and story. China preserved similar traditions. Early texts record floods that returned after long intervals, along with stories of firestorms, sudden winters, and disruptions in the regularity of seasons. These accounts often mention astronomers observing unusual patterns in the sky before these events. Some texts describe stars moving in unfamiliar ways, or celestial bodies appearing brighter than normal. Chinese scholars integrated these observations into their calendars, creating systems that tracked not only seasonal cycles, but also longer periods that might correspond to environmental shifts. This indicates an effort to use astronomy as a tool for understanding disturbances that felt cyclical. Indigenous cultures across the Americas maintained oral histories that preserved memories of ancient catastrophes. These histories were repeated in ceremonies, dances, and storytelling traditions intended to retain knowledge across generations. Some tribes described events involving fire falling from the sky, followed by long periods of darkness. Others described times when the land was covered by water far beyond normal flooding. These accounts often included descriptions of community migrations, resource scarcity, and changes in animal populations. Through these stories, people preserved information about how their ancestors survived earlier disruptions. In Polynesia and the wider Pacific region, stories describe islands sinking beneath the sea or rising from the ocean floor. These accounts align with geological changes caused by volcanic activity, tectonic shifts, and sea level rise. Yet some stories include descriptions of the sky darkening for extended periods. Others mention celestial objects that appeared unexpectedly, creating fear among observers. These memories were preserved through chants, genealogies, and mythic narratives that maintained continuity across long stretches of time. Africa also holds deep traditions of remembering environmental change. Many cultural groups retain stories describing intense droughts followed by periods of flooding. Some recount the earth shaking or splitting. Others describe long darkness, or skies filled with glowing material. These accounts preserve details consistent with geological evidence of volcanic eruptions, climatic shifts, and atmospheric dust. They also show a recognition that these events were not random. Communities treated them as part of a repeating pattern, even if the exact timing remained unclear. The Aboriginal peoples of Australia maintain some of the oldest continuous oral traditions in the world. These traditions preserve details of ancient coastlines that existed more than 10,000 years ago. They describe rising seas, disappearing lands, and changes in river courses. Modern geography confirms these details, showing that oral stories preserved accurate environmental memory for thousands of years. Some stories also describe bright streaks in the sky, loud detonations and fire spreading across the land, matching known impacts and atmospheric events. Here again, stories behave like memories, carrying forward knowledge that predates written history. If myths behave like memories, their structure offers insight into how ancient peoples interpreted large-scale cycles. These stories often begin with a period of stability, followed by signs of change. These signs might include unusual celestial events, long dry seasons, or shifts in animal behaviour. Then comes a period of destruction, usually involving fire, water, wind, or darkness. Afterward, the world renews itself. New growth appears, communities rebuild, cultures reorganise. This narrative pattern matches what would happen if civilizations were responding to recurring environmental disturbances tied to distant influences. Myths also serve as teaching tools. They provide guidance on how to respond to future dangers. In some traditions, certain signs in the sky indicate that a period of upheaval may be approaching. These signs include bright comets, unusual colours at sunrise or sunset, or extended periods of dim light. They also include animal migrations or irregular seasonal patterns. In many cultures, these signs were incorporated into rituals or taboos. Elders told younger generations what to observe, when to move, or how to prepare. These instructions preserved practical survival knowledge encoded in symbolic language. Another key aspect of myths behaving like memories lies in how they preserve the emotional weight of past events. When people live through a catastrophe, the experience stays with them. It shapes behaviour, decisions, and cultural identity. Over generations, the emotional truth of the event remains even if the details change. Myths capture this truth, embedding fear, hope, resilience, and awe into narratives that outlast the physical traces of the event itself. This emotional continuity reinforces the idea that myths serve as a memory system rather than fantasy. Some myths include descriptions of celestial bodies associated with destruction or renewal. These bodies are sometimes portrayed as gods, animals, or divine messengers. They follow paths across the sky or return after long absences. While these descriptions are symbolic, they often align with the idea of a long-orbiting object influencing Earth at intervals. Ancient people would not describe such an object with modern terminology. They would interpret it through existing cultural frameworks. Over time, the object becomes a character in the story, carrying the memory of its influence. The consistency of these symbols across regions suggests that different cultures experience similar patterns of change. While the stories vary in detail, the core elements repeat. A world once stable becomes unstable. The sky behaves unusually. Fire or water dominates. Darkness lingers. Renewal follows. These elements mirror geological and climatic records showing waves of disturbance. When stories align so closely with physical evidence, they gain credibility as carriers of real historical memory. Archaeological discoveries support this interpretation. Some settlements contain layers of material indicating sudden abandonment. These layers often contain ash, flood sediments, or debris suggesting rapid environmental change. Later layers reveal reoccupation after conditions improved. These cycles of abandonment and return align with mythic narratives describing cities destroyed and rebuilt. The physical evidence mirrors the cultural memory, reinforcing the idea that myths preserved a record of real events. Some cultures preserved memory through architecture. Structures aligned with celestial markers could serve as warning devices. If the rising position of a certain star shifted unexpectedly, it could indicate changes in Earth's tilt or orbit. If a bright object appeared in a predicted region of the sky, it might signal a recurring disturbance. Temples, stone circles, and observatories often serve dual purposes as spiritual centres and environmental monitoring systems. Their alignments act as silent witnesses to the importance early civilizations placed on the sky's behaviour. As myths travelled across generations, some evolved into more elaborate cosmologies. Ideas about ages of the world, cycles of destruction, and cosmic rhythms became part of broader philosophical systems. These systems helped people understand their place in time. They also provided frameworks for predicting the future based on the past. If the world had been destroyed once, it might be destroyed again. If destruction had followed certain signs, those signs could be watched. This created a cultural memory loop reinforced by story and observation. In later civilizations, scholars attempted to interpret these myths more systematically. Greek philosophers studied stories of floods, fires, and cosmic cycles. Middle Eastern scholars compared their traditions with those of neighbouring cultures. Indian scholars developed mathematical models aligned with spiritual cycles. Chinese scholars documented celestial events alongside natural disasters. Across these societies, intellectual efforts expanded the mythic memory system into broader systems of knowledge. When modern science entered the study of myths, researchers found surprising accuracy in many traditions. Stories considered purely symbolic sometimes described events with geological or astronomical relevance. Accounts of land sinking or rising matched tectonic changes. Stories of firestorms matched evidence of impacts. Descriptions of long darkness matched volcanic eruptions or atmospheric dust events. These correlations demonstrate that myths contain fragments of memory that survived long after their original context faded. This does not mean every mythic detail reflects literal truth. Symbolism, metaphor, and cultural interpretation shape narrative form. But beneath these layers lies the core experience of living through environmental upheaval. The memory of these experiences persisted because cultures needed to remember. They needed to pass on knowledge about how to survive future cycles. Myths served that need. The idea that myths behave like memories also connects to how civilizations understood time. In many cultures, time was not linear. It moved in cycles, reflecting the patterns of nature. Repeating ages, repeating disasters, and repeating renewals fit naturally into this worldview. If the world had been reshaped before, it could be reshaped again. If ancestors survived, descendants could survive too. This cyclical understanding of time helped preserve memory across long intervals. As we move deeper into this exploration, the next part turns to the physical evidence left in stone, clay, soil, and sky. These clues bridge the gap between mythic memory and scientific observation, revealing how ancient people did not merely tell stories, but recorded real patterns that shaped their world and prepared future generations for the cycles they believed would return, allowing the narrative to move forward without pause. Long before written language stabilized into permanent records, human beings relied on their surroundings to anchor meaning. The sky served as both a calendar and a compass, a source of guidance and a point of orientation that remained steady across generations. The stars offered a canvas of regular motions that early cultures learned to interpret with remarkable precision. As societies gained stability and resources, they began building structures that aligned with these celestial patterns. Some of these structures remain intact today, silent watchers of ages long gone. Their stones, orientations, and engravings hint at a profound effort to track changes in the sky, as if early peoples understood that the heavens carried messages essential for survival. Many ancient structures around the world share a common trait: intentional alignment with the sun, the moon, or particular stars. These alignments are too precise to be coincidence. They reflect long-term observation, careful measurement, and the belief that celestial cycles were fundamental to understanding time, seasons, and the rhythms of life. Predictable cycles such as solstices and equinoxes were essential for agriculture and ritual timing. But buried within these alignments lie traces of something more complex. In many locations, certain stones or architectural features do not align with common solar or lunar markers. Instead, they point toward regions of the sky associated with rare celestial events or unusual movements. Some researchers propose that these alignments reflect attempts to track not only visible planets, but also long-term irregularities or cycles that influence the natural world. A wandering object with an elongated orbit would not leave obvious traces in daily observation. Its movement would be slow, subtle, and invisible for most of its cycle, but its effect could influence star positions, solar patterns, and environmental conditions in ways noticeable to careful observers over many generations. If ancient cultures recognized these influences, even without seeing the object itself, they might have built structures to monitor the signs associated with its passage. One of the most striking examples is found in the ancient structures of Mesopotamia. Ziggurats, temples, and observatories scattered across the region reveal a deep engagement with the heavens. Their builders tracked planetary cycles with astonishing accuracy. They recorded retrograde motion, lunar phases, eclipses, and star risings. Clay tablets describe periods when certain celestial bodies behaved irregularly, or when bright objects appeared unexpectedly. These records blend astronomical precision with mythic symbolism, suggesting that early scholars saw the sky as a place where divine forces manifested. If unusual cycles disrupted familiar patterns, these disruptions would have been interpreted as signs of returning cosmic influences. In Egypt, temples oriented toward solstices reflect a similar dedication to tracking the sun's annual path. Some temples also align with stars whose positions shifted slowly due to precession. Egyptian priests maintained records spanning centuries, allowing them to notice long-term trends. Certain structures appear to incorporate adjustments for changes in star positions that occurred over thousands of years. These adjustments imply that the architects understood the sky's slow drift and built monuments intended to remain relevant through cosmic cycles that exceeded human lifetimes. If an irregular cycle disrupted the expected patterns, these temples could serve as reference points to track those deviations. Across the Mediterranean, early Greek and Minoan structures also show evidence of sky tracking. Minoan palaces in Crete contain light shafts and corridor alignments that mark specific solar positions. Some alignments appear designed not only for solstices, but for events occurring at longer intervals. Greek astronomers developed mathematical systems to predict planetary movements. Their work relied on centuries of observation from earlier cultures. Through this lineage of knowledge, irregularities in celestial behaviour would have been noticed, discussed, and incorporated into early cosmologies. Farther east, ancient structures in India, such as the stone arrangements at Varanasi, or the astronomical instruments of later eras, reveal a long-standing concern with tracking the heavens. Texts describe cycles lasting thousands of years, divided into ages marked by environmental change and celestial adjustments. While framed in symbolic terms, these cycles may encode observational memory of long intervals between disturbances. The idea of a world influenced by distant celestial forces fits naturally into these frameworks. Temples aligned with star positions or solar paths indicate that early Indian astronomers monitored the sky, with attentiveness extending beyond common seasonal needs. In China, astronomical observation was tightly integrated into governance. Dynasties maintained observatories staffed by scholars tasked with monitoring the sky for patterns and anomalies. Records spanning thousands of years document irregularities in star positions, atmospheric disturbances, and unusual lights in the sky. Some entries describe long-term trends inconsistent with predictable cycles. These observations influenced court decisions, agricultural planning, and ritual practices. If disturbances aligned with environmental instability, the connection between sky and earth became even more strongly reinforced. Indigenous cultures across the Americas also built structures aligned with celestial markers. The Maya constructed elaborate observatories where priests tracked planetary cycles with accuracy unmatched until modern times. They created calendars spanning thousands of years, some of which incorporate cycles longer than any human lifespan. These calendars divide time into large blocks associated with transformations in the natural world. The alignment of temples with celestial events allowed priests to monitor shifts that might indicate approaching changes. In the Andes, the Inca and earlier cultures used pillars, windowed temples and standing stones to track the sun's movement across the horizon. These alignments marked solstices, equinoxes, and intermediate solar positions. They also provided reference points for monitoring unusual sky conditions. In regions where celestial behaviour shaped agriculture and water management, maintaining accurate sky knowledge was vital. Any deviation in the sun's path or star positions could signal changes in climate or weather. Further north, the ancient structures of North America reveal a similar dedication to tracking the sky. Some mounds and circular arrangements align with solar and lunar cycles. Others align with star positions that shift slowly over long periods. These alignments reflect deep knowledge of cycles that extend far beyond seasonal patterns. Oral histories preserved by tribes include references to sky changes, bright objects appearing unexpectedly, and long darkness. These stories hint at memories preserved through both architecture and narrative. Australia's Aboriginal cultures preserve vast astronomical knowledge embedded in songlines, stories, and ground arrangements. These traditions include detailed star maps encoded in oral memory. They also include references to long-term changes in the sky, such as alterations in brightness or position. The accuracy of these traditions demonstrates that ancient observers noticed variations that might escape casual viewing. If long cycles influence conditions on Earth, these changes would have been incorporated into story and structure. Throughout these cultures, architecture served as a stable marker in a shifting world. Stones remain fixed even as the sky moves. By aligning structures with celestial markers, early people created systems for detecting long-term changes. If the rising point of a star drifted over centuries, these alignments recorded the shift. If the path of the sun changed slightly, the angle of sunlight entering a temple or passing through a stone portal changed as well. Observers could detect deviations from expected patterns, allowing them to adjust calendars, rituals, or agricultural practices. This architectural memory becomes even more intriguing when unusual alignments appear. Some structures point toward regions of the sky where no prominent stars reside. Others align with points that would have matched star positions thousands of years earlier, but no longer do. Such alignments may reflect efforts to track long-term cycles associated with objects that move slowly or irregularly. If an event in the sky appeared only once every few thousand years, its memory might be preserved through alignment rather than written record. Early cultures used star maps not only as navigation tools, but also as temporal frameworks. By mapping the sky, they created charts that connected celestial events to historical and environmental changes. Some star maps show constellations in shapes that differ from modern interpretations. These differences may reflect earlier sky conditions or cultural priorities, but they also raise the possibility that ancient observers noticed variations caused by large-scale cycles. When myths describe gods or celestial beings travelling long paths through the sky, these stories often correspond to astronomical phenomena. Some gods follow elongated routes, disappearing for long periods and returning unexpectedly. These narratives mirror the behaviour of long-period comets or distant objects with stretched orbits. Even if the mythical figures do not represent literal celestial bodies, they may encode memory of rare sky events observed by ancestors. Some myths describe the sun behaving irregularly, dimming, shifting, or altering its path. In some cultures, the sun is said to have risen in different locations in earlier ages. These descriptions align with environmental changes that can alter light scattering, atmospheric clarity, or horizon shape. They also resemble what observers might perceive if slight alterations in Earth's tilt or orbit affected solar position. If these changes were triggered by distant gravitational influences, early people would have interpreted them as evidence of a wandering celestial force. Ancient astronomers kept long records precisely because they understood the importance of tracking cycles. Many civilizations experienced several generations of relative stability, followed by sudden disruption. These disruptions inspired deeper attention to the sky. Observers sought patterns that could predict future disturbances. Star maps evolved from simple tools into complex systems capable of recording centuries of data. When later generations noticed shifts that earlier records did not show, they interpreted them as signs that larger cycles were unfolding. The durability of stone made it an ideal medium for preserving memory. Even when cultures collapsed or migrated, their structures remained. Later, peoples inherited these monuments without always knowing their original purpose. Yet the alignments persisted, testifying to a time when sky knowledge shaped architecture. The consistency of certain orientations across continents suggests that different cultures independently recognize the importance of monitoring the heavens for long-term changes. Some modern researchers propose that ancient star maps contain references to sky conditions that differ from those documented in recent history. These maps include depictions of stars not currently visible from certain latitudes, or portray constellations in positions that no longer match present alignments. While these differences can be explained by precession, some cannot be easily reconciled. They may reflect memories of sky observations made at times when conditions were altered by atmospheric dust, climate shifts, or celestial disturbances. Even the pyramids of Mesoamerica incorporate star knowledge into their construction. The interplay of light and shadow on these structures during equinoxes and solstices reveals an advanced understanding of solar movement. Some structures also align with stars that appear only during specific epochs. These alignments indicate that builders intended their monuments to preserve knowledge of sky phases that unfolded over much longer intervals than a human lifetime. In South America, the ancient city of Tiwanaku includes stone structures aligned with solar events that occur infrequently. The precision of these alignments suggests that the builders observed the sky for many generations before selecting orientations. Some researchers note that certain alignments correspond to positions that stars held thousands of years earlier. This raises the possibility that Tiwanaku preserves memory of cycles that extended far beyond the lifespan of any single community. Structures on remote islands also reflect deep astronomical awareness. On Easter Island, for example, the Moai statues and ceremonial platforms appear aligned not only with solar events, but also with the rising and setting of certain stars important to navigation and seasonal prediction. These alignments helped islanders understand changes in their environment and plan fishing, planting, and migration activities. If long-term cycles disrupted weather or ocean conditions, sky tracking became even more critical. Across all these examples, a pattern emerges. Early cultures paid extraordinary attention to the sky, building structures that served as tools for monitoring changes across long periods. These structures become repositories of memory, preserving alignments that reflect both stable cycles and irregularities. When unusual events occurred, such as increased comet activity or atmospheric disturbances, the changes would be detectable through deviations from established alignments. Observers standing within temples or beside stone circles would notice sunlight entering differently, or stars rising at unexpected angles. This sensitivity to change allowed ancient people to link environmental shifts with celestial behaviour. When their world changed dramatically, they encoded the experience in myth, ritual, architecture, and star maps. These media preserved memory across generations, enabling communities to adapt to cycles they could not control but sought to understand. Through these efforts, the sky became not only a reflection of the present, but also a record of the past and a guide for the future. As we move deeper into this exploration, the next part turns toward the timelines buried in soil, ice, and deeper geological layers. These timelines reveal patterns that suggest ancient observers were responding to forces that operated beyond their immediate understanding, allowing the narrative to continue along its path without pause. When archaeologists, geologists, and climatologists began piecing together the deep story of Earth, they expected to find scattered disruptions shaped by local forces. A flood caused by a river overflowing its banks, a fire sparked by lightning, a cold spell triggered by volcanic ash, a drought induced by shifting winds. These isolated incidents fit the expectation that nature behaved unpredictably, but within boundaries that could be explained through known mechanisms. What emerged instead was a pattern that stretched across continents and ocean basins, repeating through different eras and cultures. Timelines that should have been random showed peculiar rhythm. Catastrophes that should have been isolated appeared in clusters. Long periods of stability ended suddenly, replaced by bursts of upheaval that echoed earlier ones. The Earth's memory, written in layers of soil and stone, revealed a pattern that refused to align with simple explanations. These patterns first became evident when researchers compared sediment cores from distant regions. Layers of flood debris appeared at roughly similar depths across multiple river systems. Thick bands of clay and silt deposited almost instantaneously hinted at water rising far beyond normal flood limits. Some layers contained marine sand in places located hundreds of kilometres from modern coastlines, suggesting sudden waves of unusual height. Others contained freshwater material far inland, deposited at the same time as coastal flooding in unrelated regions. These timelines pointed toward widespread events happening close together, too coordinated to be dismissed as coincidence. Earthquake timelines behaved with similar irregularity. Major quakes often grouped into clusters separated by long intervals of relative calm. These clusters did not align neatly with tectonic boundaries alone. Some occurred in interior regions not typically associated with massive seismic events. In certain layers of rock, evidence of intense ground shaking appeared alongside flood deposits. This combination indicates a sequence in which tectonic activity may have triggered flooding, or flooding may have followed environmental stress induced by broader forces. These relationships suggest that Earth's systems respond collectively to certain triggers, producing cascades of events. In ice cores drilled from Greenland and Antarctica, scientists found bands of dust, ash, and chemical signatures that corresponded to dramatic cooling periods, followed by equally abrupt warming. These changes occurred far faster than climate models predicted. Instead of gradual shifts happening over thousands of years, the ice recorded transitions happening in decades or centuries. Some layers contained microscopic debris consistent with cometary material. Others showed spikes in elements linked to volcanic eruptions. But these eruptions alone could not explain the global coordination of change. Something else appeared to be nudging Earth systems in ways that produced repeating instability. Marine sediments added further complexity. Layers rich in microfossils indicated sudden drops in ocean temperature. These drops occurred in multiple regions at the same time. Some layers contained high concentrations of metals associated with extraterrestrial dust. Others showed evidence of disrupted ocean circulation, as if the ocean's conveyor system had paused or altered its route. These disruptions would have affected climate patterns across continents, altering rainfall, temperature, and wind circulation. Such changes would ripple through ecosystems, transforming landscapes. Archaeological evidence aligns with these geological markers. Settlements across the world show repeated cycles of destruction and rebuilding. Some were abandoned suddenly, with signs of fire, flood, or tectonic upheaval visible in their final layers. Others show gradual decline following environmental stress that made agriculture untenable. In some regions, entire cultures shifted location, moving from fertile plains to higher ground, or from coastal areas to inland regions. These movements often occurred around the same periods recorded in ice and sediment layers. Civilizations responded to changes they did not understand, guided only by the immediate need to survive. The puzzle deepens when these timelines are compared across continents. Flood layers in Mesopotamia appear around the same time as flood markers in India, Southeast Asia, and South America. Although these regions are influenced by different rivers, climates, and tectonic settings, their flood timelines share enough overlap to raise the possibility of a shared trigger. In some cases, fires recorded in charcoal layers correspond to the same time periods, indicating global events that cause simultaneous environmental stress. When researchers map these events together, they form clusters occurring at intervals that approximate long cycles. These intervals vary, but they fall within ranges that suggest a repeating influence. Some clusters appear separated by thousands of years, others by tens of thousands. While not perfectly regular, they create a pattern of recurrence that challenges the idea that Earth's catastrophes are purely internal. If internal forces ruled alone, the timing of catastrophes across multiple continents would not synchronize in this way, nor would clusters appear in cycles echoed in ancient stories. Another layer of the puzzle appears in the records of volcanic eruptions. Large-scale eruptions leave clear traces in ice cores, along with cooling signatures in ocean sediments and changes in tree ring growth. Some of these eruptions align with the clusters of disturbances seen elsewhere, but volcanic eruptions alone cannot trigger simultaneous global flooding or sudden seismic clusters. These eruptions could contribute to cooling, but the broader patterns still require a unifying explanation. Solar activity adds another element. The Sun follows cycles that influence Earth's climate. Periods of low solar activity, known as minima, can cause cooling. Periods of high activity can cause warming. But these cycles occur more frequently than the major clusters seen in geological and archaeological records. Solar cycles could amplify or dampen other forces but cannot alone explain the long-term patterns. Earth's orbit and axial tilt also shift over time. These Milankovitch cycles influence long-term climate patterns and contribute to ice ages. But these cycles operate on predictable timelines. The irregularity in the catastrophic clusters does not match the steady rhythm of orbital cycles. Something with a less predictable, more stretched pattern appears to be influencing Earth at long intervals. The concept of a distant object on an elongated orbit offers one possible explanation. Such an object could disturb cometary reservoirs or trigger changes in gravitational balance affecting tectonic stress, magnetic fields, or atmospheric composition. If disturbances occurred near the object's perihelion, when it approached closer to the Sun, the resulting influx of debris or gravitational influence could cause widespread impacts on Earth. These impacts would not need to be direct. Even slight disturbances could create cascading effects across Earth's interconnected systems. If comet streams were perturbed, Earth might pass through debris clouds at predictable intervals following the disturbance. This could explain clusters of fire-related layers followed by flood layers. Increased debris in the atmosphere would reduce sunlight, alter weather patterns, and cool the surface. When the debris settled, temperatures could rebound. The sudden changes could trigger rainfall anomalies, floods, or shifts in ocean circulation. These environmental pressures could lead to societal collapse or migration. Another mechanism involves gravitational stress. Even if the distant object never approached near Earth, its influence on the outer planets could transmit subtle changes inward. These changes might alter Earth's orbit slightly or affect precession rates. Small changes in orbital mechanics can lead to noticeable climate shifts over centuries. Ancient observers tracking the sky might notice inconsistencies in star positions or seasonal changes. They would interpret these observations through mythic frameworks, creating stories about a returning object or a wandering sun. Magnetic disturbances offer another possibility. If the distant object possessed its own magnetic field, its movement through certain regions of the solar system could influence the heliosphere, altering the flow of charged particles from the Sun. These shifts might influence Earth's magnetic field, causing fluctuations that could impact climate, tectonic activity, or atmospheric conditions. Geological records show periods when Earth's magnetic field weakened or reversed. Some of these align with environmental changes, suggesting a connection between magnetic and climatic shifts. Sea level changes also reveal patterns that align with catastrophic clusters. Periods of rapid sea level rise appear in coastal sediments. These rises often follow long periods of relative stability. The speed at which some rises occurred challenges explanations limited to melting ice. They suggest abrupt changes in ocean temperature or circulation caused by external triggers. Rapid rises would inundate coastal settlements, forcing societies to migrate inland. These migrations would leave archaeological traces of sudden abandonment along coastlines. Tree ring data provides another perspective. Trees capture annual conditions in their growth layers. Periods of stress appear as narrow rings, indicating drought, cold, or disease. Periods of flourishing appear as wide rings. Across continents, tree ring records show synchronized periods of stress, matching sediment and ice core signatures. This synchronized stress appears repeatedly at intervals aligning with catastrophic clusters. These patterns reinforce the idea that Earth's biosphere responds collectively to certain triggers. When summarizing all these clues, the timeline reveals itself as a complex interplay of forces. Geological layers show environmental shifts, ice cores show atmospheric changes, marine sediments show oceanic disruptions, archaeological sites show cultural transformations, star maps and monuments show sky-based observations. Mythic narratives preserve emotional and practical memory. These sources, though distinct, converge on a pattern of repeated, widespread disturbances separated by long intervals. These intervals do not align with human expectations of randomness. They do not follow steady cycles like the seasons. They create a timeline that appears to pulse through Earth's history, challenging the notion of isolated catastrophes. The world behaves as if responding to influences both internal and external, triggered by forces that do not adhere to predictable rhythms, but still follow broad patterns. Ancient people lived close to the land and sky. They observed these patterns as best they could. Some built monuments to track them. Others preserved stories warning of repeated cycles. The memory of earlier upheavals guided decisions made generations later. This cultural memory shaped migrations, architectural practices, and agricultural choices. Even after the original context faded, the awareness of recurrence lingered. Modern science, with tools far exceeding the observational abilities of ancient societies, now uncovers the layers of these cycles. But even with advanced instruments, the puzzle remains incomplete. Certain intervals appear too coordinated to be internal. Certain clusters align too closely with mythic accounts to be ignored. Certain anomalies resist easy explanation. The timeline continues to reveal itself as irregular yet patterned, chaotic yet rhythmic, unpredictable yet familiar. It suggests that Earth has been shaped by forces arriving from beyond, forces capable of touching climate, oceans, tectonics, and human society at once. As this exploration continues, the next part turns toward the stories of visitors in the chaos, the figures who appear in myths during times of upheaval, and the possibility that ancient people interpreted these cycles not only as natural events, but as signs of beings connected to the disturbances themselves, allowing the path ahead to unfold without pause. As the patterns of upheaval unfold across the ancient world, another layer of memory emerges from cultures that tried to explain the origins of sudden change. These memories do not only describe storms, fires, or floods. They describe figures who appear during times when the world loses its balance. Figures portrayed as beings not bound by ordinary human limitations. Figures linked to the sky, to long cycles, and to disruptions that aligned with periods of environmental stress. Among these figures, none occupy a more prominent place than the Anunnaki of Mesopotamian tradition. Their stories stretch across thousands of years, carried through empires, rewritten by scribes, and reshaped by religious and political change. Despite these transformations, one theme remains constant. The Anunnaki appear in eras marked by turmoil, renewal, and the reshaping of the world. The Mesopotamian world lived through repeated catastrophes. Floods swept across the land, storms surged from distant seas, periods of drought left fields barren, earthquakes toppled city walls, dust storms blotted out the sky. Each of these events left physical traces in the ground and cultural traces in the stories told afterward. The people of Sumer, Akkad, Babylon and Assyria responded by creating narratives that explain these cycles through the actions of beings associated with cosmic forces. These beings, the Anunnaki, were depicted as powerful figures whose decisions influenced the environment and the fate of humanity. The earliest records describe the Anunnaki not as distant celestial abstractions, but as tangible presences. They lived not in unreachable realms, but in specific cities, temples and regions. Each had roles tied to agriculture, water management, storms, judgment, or creation. These roles reflect the central concerns of early societies struggling to survive in an environment prone to instability. When floods destroyed crops or droughts threatened food supplies, people looked to these divine figures for explanations. As cities rose and fell, scribes recorded their histories alongside the traditions of the Anunnaki. Some texts describe times when these beings guided humanity, teaching skills necessary for survival. Others describe times when they withdrew, leaving humanity to endure hardship. Some portray them as protectors. Others portray them as enforcers of balance. In all versions, their presence aligns with the cycles of environmental change, reflected in geological and archaeological records. The image of visitors arriving during chaos also appears in other cultures. The Anunnaki represent a Mesopotamian interpretation of this pattern, but similar portrayals exist globally. Figures from different regions share characteristics associated with advanced knowledge, celestial origins, or links to long cycles. These similarities suggest that different societies attempted to explain recurring upheavals by personifying the forces that shaped their world. In Mesopotamia, the Anunnaki were associated with specific points in time marked by transformation. The kings on the Sumerian king list ruled for impossibly long periods before a great flood reset civilization. These long reigns may represent attempts to compress ancient memory into a framework understandable to later generations. The flood itself appears to reflect a historical event supported by archaeological evidence. A layer of flood sediment discovered in multiple city-states aligns with the period described in the legends. After the flood, the king's reigns shortened dramatically, reflecting a shift from mythic memory to historical record. The idea that the Anunnaki were present during these transitions reflects the belief that extraordinary events required extraordinary explanations. When cities collapsed or new dynasties emerged, people turned to the stories that had shaped their understanding of the world. The Anunnaki became part of that framework, representing forces that rose and fell with the cycles of the earth. The Anunnaki appear not only in flood narratives, but also in stories related to agriculture, metallurgy, architecture, and law. These stories suggest that the earlier civilizations associated leaps in knowledge with the arrival of these figures. Agricultural techniques, water management systems, and early writing are all described as gifts from divine beings. These innovations often appear in archaeological layers following periods of upheaval. After floods receded or after droughts ended, communities rebuilt with new methods that improved their ability to endure future disruptions. The stories that survived framed these innovations as interactions with the Anunnaki. The idea of visitors arriving in times of chaos does not require literal interpretations of the stories. It reflects a deeper cultural memory of knowledge emerging when conditions force societies to adapt. During upheaval, the need for new systems becomes urgent. Communities develop new techniques, adopt new practices, or reorganize leadership. Later generations interpret these shifts through mythic narratives. The Anunnaki become symbols of transformation, representing the forces that shape civilization during its most vulnerable moments. As Mesopotamia expanded its reach, the stories of the Anunnaki travelled with its culture. different city-states emphasized different aspects of these beings. Some focused on their roles as judges, others emphasized their roles in creation, others connected them to specific aspects of nature. These varied portrayals reflect local concerns shaped by environmental conditions. In flood-prone regions, the Anunnaki were associated with water. In arid regions, they were associated with storms or the heavens. This adaptability kept the stories relevant as environmental cycles continued. Over time, as new empires rose, the Anunnaki became part of larger pantheons. The Babylonians reinterpreted them within their own cosmology. The Assyrians redefined them according to their imperial ideology. Yet through all these changes, the Anunnaki retained a connection to cycles of upheaval and renewal. Their roles evolved, but the underlying association endured. The stories of the Anunnaki also reveal an awareness of long cycles that exceeded human lifespans. Some texts describe periods lasting thousands of years, others describe ages separated by catastrophe. These descriptions align with geological cycles revealed by modern science. While the stories use symbolic language, the structure reflects memory of long intervals between events that reshaped the land. The Anunnaki become markers of these intervals, appearing in legends that anchor memory across generations. In some texts, the Anunnaki are associated with celestial events. They appear in stories involving stars, unusual lights, or movements in the sky. These descriptions reflect the close connection between ancient cultures and astronomy. Observers track the heavens carefully, looking for signs of change. If unusual celestial events aligned with environmental disruption, the stories created around them preserved both elements. The Anunnaki's celestial association likely stems from this integration of sky observation into cultural memory. Later civilizations preserved these associations even as they changed the details. Greek, Persian, and early Arab scholars studied Mesopotamian astronomical records and integrated them into their own systems. They noticed that certain patterns in the sky aligned with historical changes. These alignments reinforced the idea that celestial forces influenced the world. The Anunnaki, recast in different cultural forms, persisted as symbols of this connection. In many ancient accounts, the arrival of the Anunnaki or similar beings occurs during periods of instability. These periods reflect times when environmental or societal conditions forced communities to reorganize. The stories frame these reorganizations as direct interventions. Whether interpreted metaphorically or historically, they reveal that ancient people saw upheaval as a turning point shaped by forces beyond ordinary human control. Some stories describe the Anunnaki departing after major events. Their departure coincides with restoration of stability. This pattern mirrors the cycles seen in geological timelines. After catastrophic clusters, conditions stabilize for long periods. Societies rebuild, expand, and innovate. These stable periods become golden ages in mythic memory. When the next cycle arrives, the stories link the return of upheaval with the return of the Anunnaki or equivalent figures. This interplay between stability and turmoil shaped Mesopotamian worldviews. The Anunnaki were neither wholly benevolent nor wholly destructive. They represented balance. When the world drifted out of balance, events associated with their presence restored equilibrium. This balance extended to natural forces. Floods could destroy but also renew. Storms could devastate but also cleanse. Fire could consume but also create fertile soil. The Anunnaki embodied the dual nature of these forces. Other cultures held similar beliefs. In Mesoamerica, the gods associated with celestial cycles appear during periods of upheaval. In India, divine figures appear at the end of each age to restore order. In Egypt, gods linked to cosmic balance intervene during times of environmental stress. These patterns reflect a shared attempt to understand recurring upheavals as part of a larger cycle guided by forces represented as divine figures. When considering the Anunnaki through this lens, they represent more than individual deities. They represent memory encoded in narrative, architecture, and tradition. Their stories preserve knowledge of cycles that shaped the earliest civilizations. They serve as markers of times when the world changed rapidly, forcing adaptation and innovation. Some modern theories attempt to link the Anunnaki directly to a distant celestial object such as Nibiru. These theories interpret the stories as reflections of real visitors connected to a long orbital cycle. While these interpretations remain speculative, they reflect the underlying cultural memory of long intervals and celestial associations. Whether literal or metaphorical, the stories reveal a recognition that the world responds to forces beyond immediate understanding. Ancient people experienced upheavals they could not explain through ordinary means. Floods arrived with little warning. Storms raged for years. Fires burned across entire regions. Skies dimmed or brightened unexpectedly. Animals migrated in unusual patterns. Seasons shifted unpredictably. These experiences shaped their worldview. They saw explanations that connected these events to cosmic cycles. The Anunnaki became part of that explanation. The enduring nature of the Anunnaki in cultural memory suggests that their stories carried more than entertainment value. They served as frameworks for understanding change, survival, and renewal. They offered continuity in a world defined by instability. They preserved lessons that helped communities prepare for future upheavals. As we continue through this exploration, the next part turns toward the scientific perspective, examining whether a stray planet or long-orbiting body could indeed influence Earth in ways that match the ancient memory of upheavals, bridging mythic interpretation with physical possibility and allowing the narrative to move forward naturally. The deeper both myth and geological record reach, the more they point toward forces deeper than ordinary environmental behaviour. The Earth is a complex system shaped by internal processes, yet it responds with sensitivity to influences far beyond its surface. Volcanoes erupt from the pressure of molten rock. Winds form from pressure differences in the atmosphere. Tides rise and fall with the pull of the moon. Oceans circulate according to temperature gradients driven by sunlight. These processes operate within familiar boundaries until something nudges them out of balance. When this happens, the world reacts as a single organism, sending signals across continents through shifting water, disrupted air currents, and altered seasons. For the ancient world, the triggers behind these reactions were not always clear. For the modern world, they still are not entirely clear. The possibility of a stray planet with a long-stretched orbit influencing these systems raises questions about the limits of gravitational force. Even at great distances, gravity acts on every object in the solar system. The strength of the pull depends not only on distance, but also on mass, velocity, and the shape of the orbit. A body approaching from a distant region would accelerate as it neared the Sun. Its gravitational influence would increase as well, not enough to tear Earth from its orbit or cause immediate destruction, but enough to create subtle disruptions. These disruptions, accumulated over time, could shift patterns that define life on Earth. Scientists studying celestial mechanics understand that small gravitational nudges can produce large effects over long periods. The entire arrangement of planets around the Sun is the result of billions of years of gravitational negotiation. The outer planets shape the paths of comets. Comets shape the distribution of smaller debris. Even the positions of planets influence each other. This interconnected system behaves like a vast orchestra in which each member affects the others. Introducing a new instrument into this orchestra, even one that plays infrequently, changes the entire arrangement. When astronomers simulate long-term orbital behaviour, they find that adding a distant massive object creates patterns of disturbance. These patterns affect the orbits of small icy bodies in the outer solar system. They cluster in similar directions. They shift into elongated paths. They align in unexpected formations. This clustering has been observed in real objects, giving rise to theories that something large and unseen lies far beyond Neptune. This hypothetical object is often called Planet 9. Its existence remains unconfirmed, but the gravitational fingerprints it appears to leave offer intriguing support for similar theories. If a large body moves through the outer regions on an elongated orbit, it could disturb reservoirs of small icy bodies located far beyond Pluto. These reservoirs, known as the Kuiper Belt and the Oort Cloud, contain trillions of fragments. Most remain steady, moving slowly in predictable paths, but a slight nudge from a passing body could dislodge some of them. Once disturbed, they fall toward the Sun, becoming comets. The journey takes thousands of years, but eventually they enter the inner solar system. Some break apart, forming streams of dust. Others collide with planets or burn in the atmosphere. Even without direct impacts, the presence of more dust can affect Earth's climate. Earth's atmosphere is sensitive to changes in incoming sunlight. Dust in the sky can cool the surface, altering temperature patterns across continents. A cooler surface changes rainfall distribution, ocean circulation, and wind behaviour. These changes appear in ice cores as abrupt shifts in chemical composition. They appear in ocean sediments as changes in microfossil populations. They appear in archaeological layers as cultural disruption. A stray planet would not need to approach Earth closely to trigger these effects. It would only need to disturb the outer reservoirs enough to increase the number of objects entering the inner system. Another mechanism through which a distant object could influence Earth lies in gravitational resonance. When celestial bodies fall into periodic alignment, they push and pull on each other in subtle ways. These resonances can change orbital behaviour over long periods. If a large object with a long orbit repeatedly passed through the same region, even at great distances, its periodic influence could shift Earth's orbit slightly. These shifts would be tiny, imperceptible in daily life, yet significant over geological time. Slight changes in Earth's distance from the Sun or tilt of its axis could alter climate cycles. These changes might help explain periods of warming, cooling, or instability recorded in sediment and ice. Scientists have documented that Earth's axial tilt changes naturally over tens of thousands of years. This tilt determines the severity of seasons. A greater tilt produces more extreme seasonal differences. A lesser tilt produces milder seasons. If an external gravitational force amplified or dampened this natural cycle, it could create periods of instability. Ancient people may have noticed these changes in the length of daylight or the position of sunrise. These observations, passed down through generations, became part of mythic narratives, describing ages when the sun behaved differently. Earth's core also responds to gravitational forces. The molten iron within it moves continually, generating Earth's magnetic field. If external forces altered the flow of this molten material, the magnetic field could weaken or shift. Paleomagnetic studies show that Earth's magnetic field has undergone reversals and excursions throughout history. During these periods, the field weakens, making Earth more vulnerable to cosmic radiation. Increased radiation can alter climate and affect biological systems. Some reversals align with environmental upheavals. While internal processes play a major role, the possibility that external gravitational influences contribute to these changes remains under study. Ocean tides provide another example of Earth's sensitivity to gravitational forces. The Moon's influence on tides is obvious, but the Sun also plays a role. When their pulls align, tides increase. When their pulls oppose each other, tides decrease. A large distant object, even one that never approaches the inner solar system, could exert enough gravitational force to alter tidal behaviour slightly. These alterations might influence ocean circulation, which in turn affects climate. Ocean currents act like a conveyor belt, distributing heat across the planet. If this conveyor slows or shifts, the result can be dramatic temperature changes, droughts, or flooding. Earth's crust also responds to gravitational stress. Tectonic plates sit atop a layer of molten material that moves slowly. Gravitational forces from celestial bodies influence this movement. While the effect of distant objects is minimal compared to internal forces, Periodic influences over long cycles could contribute to increased tectonic activity. Clusters of earthquakes, volcanic eruptions, and crustal shifts might reflect more than simple internal pressure. They may reflect external nudges amplified by internal processes. Scientists studying the Earth's long-term behavior recognize that its systems do not operate in isolation. Climate, geology, magnetism, and the biosphere interact continuously. A disturbance in one area ripples through all others. This interconnectedness creates sensitivity to influences that might otherwise seem too small to matter. A slight change in sunlight, a small shift in comet activity, or a subtle alteration in orbital mechanics can cascade into significant effects. These cascades match the pattern seen in both geology and myth, where large changes often follow subtle precursors. Some researchers explore the possibility that Earth's orbit passes through regions of space containing higher concentrations of cosmic dust. These regions might be remnants of ancient collisions or debris fields created by long-orbiting bodies. When Earth travels through these regions, dust enters the upper atmosphere, reducing sunlight and cooling the surface. Geological records show periods of global cooling that align with increased dust signatures. These cooling periods often precede environmental disruptions reflected in archaeological layers. If a stray planet influenced the formation or movement of these dust regions, it could indirectly affect Earth's climate. Dust cycles could align with the planet's long orbit, creating recurring periods of cooling or instability. Ancient observers would not understand the role of dust, but they would notice changes in sky color, reduced brightness, or extended twilight. These conditions appear in myths describing dim skies or weakened sunlight. Another scientific avenue involves gravitational lensing. A massive object passing between Earth and distant stars could alter the apparent positions of those stars. Ancient astronomers tracking celestial patterns might notice subtle shifts in star arrangements. Such changes could inspire stories of moving heavens, wandering gods, or disrupted cosmic order. These stories may encode memory of the observational anomalies linked to long-cycle disturbances. Even without direct observation, the presence of a stray planet could influence cultural memory through the effects it triggers. Increased comet activity, atmospheric dust, magnetic fluctuations, and orbital changes all produce physical consequences that ancient societies experienced directly. These consequences became integrated into mythic frameworks. The stray planet becomes a symbolic representation of the forces behind the upheavals, whether or not it was ever seen. Modern science has not dismissed the possibility of undiscovered large objects in the solar system. Observations of distant icy bodies reveal patterns that cannot be fully explained by known planets. The concept of Planet 9 or similar objects remains a viable hypothesis. While no telescope has yet captured direct evidence, the gravitational signatures persist. These signatures echo the ancient idea of a wandering force returning at long intervals. The influence of a stray planet does not violate known physics. It operates within the boundaries of gravitational, magnetic, and orbital mechanics. The challenge lies in detecting such an object across vast distances. The outer regions of the solar system are dark, cold, and sparsely illuminated. Objects there reflect little sunlight. Even large bodies become nearly invisible. Modern surveys continue to search, but the sky is immense. Failure to detect does not negate the possibility. If a distant world exists on an orbit thousands of years long, it would spend most of its time far from the sun, moving slowly through the darkness. Only during its brief inward journey would it move fast enough or reflect enough light to be detectable. Even then, detection would require looking at the right region at the right moment. Ancient observers lacked the technology to see such an object, but they recorded the effects of cycles that resonate with patterns such an orbit might cause. In this way, the question shifts from whether a stray planet passed near Earth to whether Earth systems reacted as if something had disturbed the larger environment. geological and climatic records suggest repeated disturbances. Myths describe long cycles of destruction and renewal. Architecture encodes observations of celestial anomalies. These layers support the idea that ancient peoples sense patterns shaped by forces beyond immediate understanding. Modern models continue to evolve. Simulations explore how distant bodies could influence cometary paths, magnetic fields, and orbital mechanics. These simulations reproduce some of the irregularities seen in real data. They also produce cycles matching the timing of certain geological clusters. While not conclusive, these results support the idea that external forces contribute to Earth's long-term behaviour. The universe is filled with objects that follow paths shaped by forces both simple and complex. Some move in neat circles. Others follow elongated arcs that carry them into distant darkness and back again. Some interact through resonance, others through collision. Earth is part of this tapestry, responding to influences both near and far. Understanding these influences requires bridging mythic memory with scientific exploration. As this journey continues, the next part turns toward the human response to these possibilities. Not the scientific perspective, nor the mythic interpretation alone, but the place where belief, skepticism, and curiosity intersect. The next part explores how thinkers across time, from ancient scholars to modern scientists, have grappled with the puzzle of forces that might shape Earth from afar, allowing the narrative to move forward without interruption. Throughout history, the mystery of long cycles has drawn people into two broad territories of thought. Some saw patterns in the stories, the sediment, the sky, and the memory of earlier ages, and concluded that these patterns pointed toward forces beyond ordinary experience. Others saw the same evidence and insisted it could be explained entirely through natural processes without invoking distant worlds or cosmic influences. Between these positions grew a space filled with debate, interpretation, and curiosity. This space became the bridge across which civilizations tried to understand the world they inherited. It remains a place where ideas continue to circulate quietly, shaped by new data, ancient memory, and the steady hum of scientific inquiry. The earliest skeptics lived in the same world as the earliest believers. Ancient cities held scholars who dedicated their lives to studying the sky with patience and precision. These scholars recognized that many celestial movements followed predictable paths. The sun rose and set with dependable rhythm. The moon cycled through phases. Planets wandered slowly across the sky, in patterns that could be tracked. These scholars developed mathematical systems to explain these motions. They used geometry, observation, and accumulated knowledge to build calendars on which entire agricultural cycles depended. Through this work, they brought stability to communities, allowing people to plan planting, harvesting, and ritual seasons. But these same scholars faced records of irregular events that defied the patterns they studied. Sudden floods, extended droughts, years of dim sunlight, and sky anomalies appeared in texts alongside their observed calculations. Some scholars treated these irregularities as beyond explanation, events caused by forces outside the predictable rhythms of the heavens. Others sought rational explanations, attributing them to storms, volcanoes, or shifting winds. These early divisions created a spectrum of interpretation in which both viewpoints existed side by side. As knowledge expanded, skepticism grew stronger. Ancient Greek thinkers, for example, challenged the idea that celestial bodies influenced events on Earth beyond the natural movements of the sun, moon, and planets. They developed early models of the cosmos that emphasized order, symmetry, and regularity. To them, the sky operated like a well-balanced mechanism. Disruption came from internal terrestrial factors, not from distant, unseen celestial forces. Yet even among them, some acknowledged that comets, eclipses, and unusual alignments held meaning. They noted that great events often followed celestial anomalies. They did not attribute these anomalies to gods or wandering planets. but recognized their significance within natural frameworks. As civilizations expanded across continents, the distance between believers and skeptics widened. Some cultures clung closely to the idea of long cycles influenced by external forces. Others embraced purely terrestrial explanations. Yet the world continued to offer events that challenged both perspectives. Volcanoes erupted with unpredictable violence. Earthquakes shattered cities without warning. Floods swept across fertile plains. Sunlight dimmed and returned. These events kept the debate alive in different forms. In the medieval period, scholars across the Near East, Europe and Asia revisited ancient texts. They studied histories describing floods, famines, firestorms, and long winters. They compared these stories to astronomical observations and geological features. Some concluded that these events happened because of divine intervention. Others believed they reflected natural cycles built into the world itself. Still others speculated about celestial influences beyond the known planets. These speculations remained within the realm of philosophy, but they preserved the idea that Earth might be part of a much larger pattern. The rise of scientific thought did not eliminate this debate. Instead, it reorganized it. As telescopes improved, astronomers observed comets, asteroids, and distant stars with clarity unknown to earlier ages. They discovered long-period comets returning at predictable intervals. They mapped the outer planets and calculated their gravitational effects. They recognized that the solar system extended far beyond the planets visible to the naked eye. These discoveries reinforced skepticism regarding mythic interpretations, yet they also revealed how gravitational influences could alter orbits, disturb debris fields, and create long-term cycles. These findings echoed elements of ancient stories even as they challenged their narrative frameworks. Some scientists viewed the long cycles of geology and climate as entirely internal. They pointed to tectonic shifts, volcanic activity, ocean circulation changes, and orbital variations as sufficient explanations. Their models demonstrated how each of these processes created environmental instability. They observed how ice ages advanced and retreated. They recognized how sediments recorded stories of floods, storms, and seismic change. They concluded that Earth required no external trigger to produce cycles of upheaval. Others saw gaps in this interpretation. They noticed that some cycles occurred too irregularly or too synchronously across continents to be explained solely by internal forces. They found layers of cometary material in ice cores coinciding with periods of disruption. They noted clustering in the orbits of distant icy bodies, suggesting hidden gravitational influences. They modelled how a distant mass on a stretched orbit could distend the fragile structure of the solar system in subtle ways. These researchers did not claim that ancient myths represented literal history. Instead, they acknowledged that ancient people recorded memories of real events that might reflect the consequences of complex long-term celestial influences. The tension between these perspectives grew in the 20th century as scientists debated catastrophic versus uniformitarian views. Uniformitarianism argued that slow, steady processes shape the Earth. Catastrophism argued that sudden, devastating events play a major role. For years, the uniformitarian view dominated academic thought. Catastrophes were considered too dramatic, too irregular, too aligned with myth to be scientifically respectable. Yet discoveries began to erode that confidence. Meteorite craters were identified around the world. Evidence of large impacts appeared in geological layers. The extinction of the dinosaurs was tied to a single impact event. Slowly, catastrophes regained scientific legitimacy. Myths describing fire from the sky, trembling earth, and rising water no longer seemed entirely symbolic. Even with these shifts, skepticism persisted. Believers in cosmic cycles saw meaning in every anomaly. Skeptics demanded evidence robust enough to meet the standards of scientific inquiry. Both positions contributed to understanding. Believers encouraged exploration of complex interconnected systems. Skeptics ensured that claims were tested rigorously. Between them, a nuanced space evolved where ideas could be examined without dismissal or blind acceptance. This space is important because it reflects how humanity processes uncertainty. The Earth's long cycles are not fully understood. They do not conform neatly to models. They defy simple explanations. They create gaps in knowledge where interpretation becomes necessary. Some fill these gaps with memory preserved in myth. Others fill them with calculations, simulations, and data. Both approaches offer insight. Myths preserve emotional truth and cultural memory. Science provides structure and measurable evidence. When combined thoughtfully, they create a more complete picture. Throughout the modern era, new evidence continued to emerge that challenged the boundaries between skepticism and belief. Ice cores revealed rapid climate shifts. Sediments uncovered layers of iridium. Astronomers discovered distant objects with unusual orbits. These discoveries supported elements of long-cycle theories, while grounding them in physical mechanisms. As the scientific record expanded, so did the space between outright dismissal and uncritical belief. Some researchers focused on debris patterns observed in the outer solar system. They found clustered orbits among distant icy bodies, suggesting gravitational influence from a large unseen mass. This discovery led to models proposing a ninth planet. These models explained the clustering with elegant simplicity. The hypothetical planet would move along an elongated orbit, completing a circuit over thousands of years. Its gravitational influence would shape the paths of smaller bodies. This possibility revived ancient ideas of wandering forces returning at long intervals. Skeptics acknowledged the mathematical plausibility while waiting for direct observation. Other scientists examined geological evidence for patterns in mass extinctions and climate disruption. Some identified cycles of about 26 million years in extinction events. Others found patterns on shorter intervals. These cycles appeared irregular but not random. Their causes remained unclear. Some proposed cosmic triggers. Others insisted internal processes were sufficient. Yet the debate itself indicated how the boundaries between mythic cycles and scientific cycles had blurred. In the cultural sphere, belief in ancient cycles grows not from scientific data alone, but from the emotional resonance of stories that survived millennia. People recognize the depth of memory preserved in myths. They sense that ancient civilizations encoded their understanding of the world in stories about gods, cycles, and cosmic order. When modern findings reveal real ecological patterns that echo these stories, interest grows in the possibility that myth and science are parallel expressions of the same deeper truth. Skeptics maintain that myth should not be conflated with data. They argue that symbolic narratives cannot replace scientific evidence. Believers argue that dismissing myth ignores humanity's oldest knowledge system. Between these poles lies a growing recognition that myth and science can inform each other without losing their integrity. Myth can inspire questions. Science can test them. Myth can highlight patterns missed by analytic approaches. Science can uncover mechanisms that explain ancient observations. This space between skepticism and belief is where some of the most interesting thinking occurs. It is where researchers consider whether the recurrence of floods, fires, and climatic shifts reflects external influence or internal cycles. It is where archaeologists examine ancient structures for clues about astronomical knowledge. It is where astronomers search for hidden planets shaping distant orbits. It is where mythologists trace narrative patterns across continents. These disciplines, once isolated, now intersect in ways that create broader understanding. As knowledge grows, the divide between skeptics and believers narrows. Skeptics acknowledge that long cycles exist and matter. Believers acknowledge that not all ancient stories represent literal history. Both sides converge on the idea that the Earth has undergone repeated periods of instability. Both accept that these periods influenced human civilization profoundly. Both recognize that understanding these cycles matters for the future. Their debates do not diminish the importance of the underlying patterns. Instead, they enrich the exploration of them. The The story of cosmic influence remains incomplete, not because of the lack of data, but because of the scale involved. Orbits spanning thousands of years exceed human observational history. Geological cycles spanning tens of thousands of years exceed written records. Mythic memory spans only as far as stories can travel. Scientific instruments have existed for only a brief moment in cosmic time. The gaps between these spans create uncertainty. Within this uncertainty, speculation endures, shaped by evidence, tradition, and intuition. Some modern theories merge these perspectives. They propose that long-orbiting bodies influence Earth indirectly through gravitational disturbances rather than direct encounters. These disturbances alter debris fields, magnetic flows, or atmospheric conditions. The effects accumulate over time, creating cycles preserved in myth and geology. These theories do not claim to prove ancient narratives. Instead, they suggest that ancient people observed real patterns that modern science is only beginning to quantify. Others remain firmly rooted in skepticism. They point to the dangers of attributing complexity to unseen forces. They emphasize the role of internal processes. They insist that extraordinary claims require extraordinary evidence. Their caution prevents the acceptance of unfounded ideas. Their rigor shapes the standards by which scientific claims are evaluated. Yet even skeptics acknowledge the reality of cosmic influence. Earth is part of a system shaped by gravity, radiation, and the movements of celestial bodies. Comets, asteroids, and dust clouds affect the planet. Solar activity influences climate. Magnetic fields shift. Cosmic rays enter the atmosphere. These influences are measurable and real. The only debate is the extent to which long-orbiting bodies contribute to patterns of upheaval. Humanity stands between ancient memory and modern science, interpreting the world through both frameworks. The space between skepticism and belief becomes a place of quiet contemplation, where ideas from both worlds can coexist without conflict. The Earth continues to reveal its rhythms. The sky continues to hold its mysteries. The story of long cycles continues to unfold. As this exploration moves forward, the next part turns toward the possibility that if the cycles existed in the past, they may still be active in the present. This continuation leads naturally into considering how modern understanding, technological insight, and renewed interest in ancient patterns might reveal the outlines of future cycles, allowing the narrative to move ahead without pause. If a long, repeating cycle has shaped the Earth's past, the story of civilization changes in subtle but important ways. History becomes less a straight ascent from simple beginnings to complex societies, and more a series of attempts to recover stability after periods of disruption. Geological layers, ancient stories, archaeological ruins, and astronomical patterns all begin to fall into place as elements of a larger rhythm. The past becomes a landscape marked not only by human choices and local conditions, but by forces that acted across continents and oceans. These forces, whether internal or influenced by something beyond Earth, would not erase human agency, but they would create the framework within which cultures rose, fell, and adapted. When looking at Earth's deep history through this lens, the first and most striking realization comes from the consistency of upheavals recorded in physical evidence. Sediment cores show layers of sudden flooding across multiple regions at similar times. Ice cores contain traces of atmospheric dust consistent with global cooling episodes. Marine sediments reveal disruptions in ocean circulation that altered climate patterns. These events appear in clusters. Between clusters lie long periods of stability in which ecosystems flourish, agriculture expands, and civilizations grow. If a cycle exists, these stable periods represent the time between disturbances. Understanding the past through this pattern reveals that many ancient cultures emerged not during periods of stability alone, but during the rebuilding phases after disruption. The earliest agricultural societies appeared after large climatic shifts. River valleys stabilized enough to support settled communities only after waters receded and soils renewed. The first cities rose in places shaped by earlier floods or fires. These environments, though shaped by upheaval, offered fertile ground for innovation. The cycle created hardship, but also opportunity. Understanding this interplay clarifies why civilizations often appeared in waves, rather than as a single continuous progression. If the cycle is real, the appearance of sudden technological or cultural leaps in the archaeological record also takes on new meaning. Innovations often cluster after disruptions. Irrigation systems appear after floods reshape landscapes. Metalworking becomes prominent after periods of resource scarcity. Writing systems emerge during times of administrative need following upheaval. Monumental architecture rises in the wake of disasters, often as attempts to restore order or create lasting stability. These leaps do not require external teachers but reflect human adaptation to changing conditions. The cycle created pressure, and the pressure produced innovation. This pattern is visible across continents. In Mesopotamia, the earliest cities developed shortly after a widespread flood event. In Egypt, unified kingdoms rose after climatic instability reduced rainfall. In the Indus region, planned cities emerged after shifts in river courses. In China, dynasties formed during transitions between environmental phases. In the Americas, complex societies appeared during periods of climatic stabilization following earlier disruption. If the cycle shaped these timelines, then the rise of civilization reflects humanity's capacity to adapt to the world's changing rhythms. If the cycle influenced Earth's past, it would explain the repeated theme of lost ages in ancient stories. Cultures around the world describe earlier periods of prosperity ended by catastrophe. They describe floods, fires, darkness, and cold. They describe rebuilding after these events. These stories persist across time because they reflect real memories preserved through narrative. They do not indicate advanced global civilizations lost without trace, but rather localized or regional societies disrupted by environmental shifts. These societies may have had knowledge suited to their environments. When those environments changed, the knowledge became less useful, or the societies had to reorganize. The cycle would also clarify why some regions show long periods of habitation interrupted suddenly. Archaeological layers contain evidence of abandonment followed by reoccupation. Settlements destroyed by floods, fires, or quakes are often rebuilt within decades or centuries. These patterns suggest that people returned once conditions stabilized. If the cycle periodically reshaped landscapes, these cycles of abandonment and return reflect human resilience rather than mystery. Understanding the cycle's influence on the past also casts new light on migration patterns. Large-scale movements of people often follow environmental pressure. Drought pushes communities toward rivers. Floods push them to higher ground. Cold drives them toward warmer regions. Resource scarcity forces them to seek new lands. These migrations shaped languages, cultures, and technologies. If the cycle repeatedly altered climate, these movements reflect responses to long-term rhythms rather than random events. The cycle also affects how we interpret early religious and cosmological systems. Many ancient traditions describe the world in terms of ages, each ending with destruction and renewal. These systems appear in Mesopotamia, India, Mesoamerica, China, and other regions. The consistency across continents suggests that ancient people observed repeated patterns in nature. They built cosmologies that reflected these observations. These cosmologies were not attempts to explain the universe at large, but to make sense of the world they inhabited. If the cycle shaped the past, then these frameworks preserve memory of real events interpreted through spiritual or symbolic language. Another consequence of accepting the cycle as real is understanding that ancient architecture served as more than ritual or political expression. Many structures aligned with celestial markers. Observatories tracked the sun, moon, and stars. These alignments allowed people to detect deviations from expected patterns. If the cycle affected the sky's appearance or the timing of seasons, ancient astronomers would record these changes. Their data might be embedded in monuments that still stand. The cycle would explain why some alignments appear designed to track long-term shifts rather than seasonal ones. If the cycle shaped Earth's past, it would also explain the consistency of global flood narratives. These stories do not require a single global event, but reflect regional events occurring close enough together to be remembered across cultures. The flooding of coastal plains due to sea level rise, the breaching of ice-dammed lakes, and torrential rains following climatic shifts could create memories that blended over generations. These events, repeated at intervals, would form a collective memory preserved in myth. Understanding the cycle's influence also helps explain why some ancient technological traditions appear suddenly, flourish, and then disappear. These traditions often emerge in the wake of environmental shifts. They represent solutions suited to particular conditions. When conditions changed again, some technologies became obsolete, others were lost because the societies that used them dispersed. The cycle did not erase knowledge directly, but altered the context in which knowledge was useful. The cycle may also illuminate why ancient people placed such importance on recording time. Calendars, star maps, and astronomical inscriptions appear across early civilizations. They served practical purposes, but also reflected a deeper desire to understand patterns that shaped life. Ancient astronomers tracked cycles not only to predict seasons, but to detect irregularities. If they observed variations in sunrise positions, star risings, or seasonal timing, they would incorporate these observations into their cosmologies. Their attention to long-term patterns suggests awareness of forces beyond their immediate environment. Accepting the cycle's reality also shifts how we view human resilience. Civilizations have survived countless disruptions. They rebuilt, reorganized, and adapted. They developed new agricultural systems, architectural techniques, and social structures. These responses reflect human ingenuity and the ability to endure environmental challenges. The cycle does not diminish humanity's achievements, but highlights the context in which they occurred. The cycle's presence in Earth's past also reshapes how we understand cultural memory. Oral traditions, myths, and religious texts preserve more than symbolic meaning. They carry fragments of experience passed through generations. These fragments include descriptions of environmental shifts, sky anomalies, and societal upheavals. When placed alongside geological evidence, these memories gain additional depth. They reflect humanity's attempt to preserve knowledge across cycles. If the cycle influenced Earth's past, it also shaped the development of trade routes, resource use, and settlement patterns. Communities adapted to new climates by shifting agriculture, building irrigation systems, and relocating resources. Trade networks adjusted as regions gained or lost productivity. The cycle created dynamic landscapes that required constant adaptation. The cycle also shaped political systems. Periods of stability allowed centralized states to form. Periods of instability weakened them or caused them to collapse. Leadership changed when environmental stress demanded new strategies. Some rulers gained power by offering solutions to climatic challenges. Others lost power when they failed to meet those challenges. The cycle influenced political timelines as much as environmental ones. Understanding the cycle's role in Earth's past brings clarity to the rhythmic rise and fall of cultures. It helps explain why civilizations emerged in waves rather than in a steady upward line. It reveals how deeply nature shaped human destiny. It highlights the fragility and resilience inherent in human society. This perspective invites re-evaluation of unexplained transitions in the historical record. Periods of rapid cultural change often align with environmental shifts. These shifts include droughts, floods, storms, cold spells, and sea level changes. Each event forced human communities to adapt. The cycle provides a framework for understanding these transitions without attributing them to purely local factors. If long cycles influenced Earth's past, then the world humanity inherited is one shaped by repeating disruptions. These disruptions did not erase humanity, but strengthened its adaptability. The past becomes a story not just of innovation and progress, but of endurance and recovery. As this exploration approaches its next stage, the story turns naturally toward the implications for the present and the future. The next part considers how these cycles, if they continue, might shape the world moving forward, and how ancient memory and modern evidence together illuminate the patterns that may still be unfolding, allowing the narrative to continue without pause. If a long repeating cycle shaped the distant past, then the question becomes how those same rhythms might unfold in the world that exists now. Every society that came before carried fragments of memory about earlier disturbances. These fragments surfaced as stories, rituals, observations, and stone markers aligned with the heavens. They preserved the idea that the world moves through eras shaped not only by internal forces, but by patterns that arrive from beyond ordinary experience. When the past is viewed through this lens, the present becomes part of a larger sequence rather than an isolated moment. The future becomes not a blank field of possibilities, but a continuation of processes that have been unfolding since long before written history began. If the cycle is real, then the world today stands somewhere along its arc. Modern science has revealed enormous detail about tectonic systems, climate dynamics, atmospheric chemistry, and stellar evolution. These discoveries describe Earth as a world shaped by complex feedback loops. It is resilient in some ways and delicate in others. It responds to subtle changes in temperature, sunlight, magnetic activity, and orbital position. These responses are recorded in ice, soil, and stone. They form patterns that echo through time. Understanding the cycle means understanding that Earth behaves like an interconnected system, responding to influences both internal and external. When external forces press upon it, the response unfolds gradually at first, and then more rapidly once certain thresholds are crossed. Past civilizations experienced these responses as environmental pressure. Today, the world experiences them through scientific measurements, satellite observations, and global monitoring networks. The frameworks have changed, but the underlying patterns remain similar. If a long-orbiting object influenced earlier periods, its effects would have been indirect rather than catastrophic. It would not need to approach Earth closely. It would only need to disturb other parts of the solar system enough to alter debris fields, shift comet trajectories, or adjust gravitational resonances. The subtle influences would ripple inward over long periods. Earth would respond through changes in climate, ocean circulation, tectonic stress, and atmospheric composition. Past cultures noticed these changes through weather, seasons, and sky behavior. Modern observers notice them through data. If the cycle is active now, its signals would appear not as singular events, but as gradual accumulations of anomalies. These anomalies would not behave in isolation. They would affect multiple systems at once. Climate models might show irregular warming or cooling phases. Ocean currents might shift in ways that alter weather patterns across continents. Magnetic readings might capture fluctuations in the protective field around the planet. Astronomical surveys might detect unusual clustering of distant objects or deviations in comet paths. None of these indicators alone prove the existence of a cycle. Together they form a pattern that mirrors what ancient people encoded into myth. If earlier ages were shaped by repeating disturbances, the world today might be entering or already within such a phase. Geological records show that Earth moves through alternating periods of stability and instability. During stable periods, climates moderate, ecosystems flourish, and civilizations expand. During unstable periods, climates shift abruptly, seas change levels more rapidly, droughts intensify, storms become more severe, and ecosystems reorganize. These transitions unfold slowly compared to human lifetimes, but quickly compared to geological time. If the present world reflects such a transition, it may indicate the approach of another part of the cycle. This does not imply that a single event shapes the future. It suggests a sequence of adjustments affecting water, air, soil, and society. These adjustments unfold unevenly across regions. Some areas experience drought while others face intense rainfall. Some regions warm while others cool. The global pattern becomes more complex with every shift. Ancient people saw these shifts through their immediate environment. Modern people see them through global networks of information. If the cycle influenced earlier human development, it may influence the trajectory of modern society. Civilizations rise through periods of environmental stability. They become vulnerable during periods of instability. Today, global systems rely on stable climate patterns to support agriculture, infrastructure, and economic activity. Even small deviations can create stress. Drought reduces crop yields. Floods damage cities. Storms disrupt supply networks. Shifts in ocean currents alter fish populations. These effects accumulate. They challenge systems that depend on predictability. If the cycle is repeating, the world might face similar pressures to those recorded in earlier eras. Ancient people responded through migration, adaptation, innovation, and cultural transformation. Modern societies have far greater technological capabilities, but they also depend more heavily on large, interconnected systems. A subtle shift in one system can affect others. The cycle's influence would therefore interact with a world far more complex than those of earlier ages. Understanding these patterns does not mean predicting specific events. It means recognizing that Earth's behavior follows rhythms shaped by forces still not fully understood. These rhythms can be seen in ice cores, tree rings, sediment layers, and historical transitions. They reveal that the Earth responds repeatedly to similar triggers. If those triggers involve external cycles, then the present day is not exempt from them. Modern astronomy offers tools that ancient observers did not possess. Telescopes scan the sky for faint objects. Space probes travel through distant regions. Surveys map the distribution of icy bodies beyond Neptune. These tools have revealed patterns suggesting gravitational influence from an unseen mass. While no direct observation has yet confirmed such a body, the indirect signs align with models predicting a long-orbiting object. If this object exists, its slow movement through distant space creates effects that unfold over thousands of years. Ancient civilizations experienced the consequences without seeing the cause. Modern civilization has the chance to detect the cause directly. If the cycle is real, understanding it would reshape interpretations of Earth's long-term climate patterns. Abrupt changes in temperature and precipitation appearing in the geological record might be linked to periods when comet debris entered the atmosphere. Sudden cooling events might align with increased dust from disturbed outer reservoirs. Widespread fires recorded in charcoal layers might reflect increased meteoritic activity. Modern science already recognizes the influence of cosmic dust on climate. A long-orbiting body could alter the cycle of dust delivery over time. This perspective would also influence how the world understands extinction patterns. Geological records show that biological diversity fluctuates in cycles. Some extinctions result from internal stresses, others appear to align with external influences. If the cycle shaped earlier extinctions, then understanding it becomes important for anticipating future biological changes. Modern ecosystems face stresses from climate change, habitat loss, and resource pressure. If these stresses combine with the long cycle influences, their effects could amplify. If a long cycle affects Earth, the present moment becomes a point along a much larger curve. The future does not need to be viewed as a period of crisis, but as a continuation of a natural pattern. Civilizations adapt, ecosystems reorganize, landscapes transform. Humanity's role becomes one of navigating the transition with knowledge that earlier cultures lacked. The tools available today, scientific instruments, global communication, predictive models, offer a far clearer view of Earth's processes than any earlier age possessed. The cycle's influence on the future would not manifest uniformly. Some regions might experience heavier rainfall, others might face desertification, storm patterns might change, sea levels might alter coastlines. These processes are already measured through rising temperatures, melting ice, and shifting currents. Whether these changes are part of the cycle, the result of human influence, or both, they contribute to a complex future shaped by multiple forces. If ancient stories preserve memories of past transitions, they may also preserve lessons about resilience. Communities that survived earlier disturbances relied on cooperation, adaptation, and an understanding of natural cycles. They adjusted agriculture to new climates. They moved settlements to safer regions. They developed technologies suited to new conditions. Modern societies may need to adopt similar strategies, but on a larger scale. Adaptation might involve modifying infrastructure, adjusting food systems, or reorganizing population centers. If the cycle is real, the future might include increased comet activity as debris fields shift. It might include fluctuations in magnetic strength. It might include climate transitions that unfold over decades. None of these possibilities guarantee destruction. They represent challenges requiring understanding and preparation. Modern science can monitor these processes in real time. This provides an advantage no earlier civilization possessed. The presence of a cycle does not diminish human responsibility for environmental stewardship. Internal stresses and external cycles can interact. Responsible management of resources and climate systems remains essential. The cycle provides context, not certainty. It frames Earth's behavior in long arcs rather than short episodes. Recognizing these arcs encourages long-term thinking. If the cycle shaped the past and influences the present, it will shape the future in ways still unfolding. The world today is not at the end of anything. It is part of a continuum stretching from deep prehistory into ages yet to come. Understanding this continuum helps ground the present moment within a larger timeline. It offers perspective on the challenges faced by modern societies. It suggests that earlier cultures did not describe their experiences in isolation. They described pieces of a repeating story the Earth has told many times. This perspective leads naturally toward a quieter reflection, which forms the path ahead. The next part explores how stories, science, memory, and observation all merge into a single thread connecting past, present, and future. It turns toward the space where these elements come together, allowing the movement of the narrative to continue without interruption. Across thousands of years, as civilizations formed, collapsed, rebuilt, and transformed, one idea persisted in the background of human thought. It appeared in quiet stories whispered by elders. It appeared in carved symbols on stone walls. It appeared in long-hair myths that travelled across deserts and mountains. It appeared in rituals marking moments when the sky shifted. It appeared in memories of floods, fires, and long winters. It appeared in the sense that the world had changed before and would change again. This idea moved silently through time, carried not by one culture alone but by many. It lingered through ages because it offered a way to understand a world that never stayed still. This idea, shaped by experience and reinforced by memory, holds that cycles larger than any human life influence the Earth. These cycles unfold slowly, beyond direct perception, but leave traces that accumulate. They alter climates, reshape coastlines, and press societies into new forms. They echo through stories because stories are how people make sense of things too large to witness directly. They echo through scientific data because data reveals patterns that match what ancient memory preserved. They echo across ages because they capture something fundamental about the human relationship with nature. When people thousands of years ago watched the sky from the rooftops of early cities, they saw patterns that repeated. The sun followed its path. Stars drifted slowly across the horizon through decades. Seasons arrived with predictable rhythm. These patterns offered stability, yet every so often something disrupted the familiar. A flood receded differently. A winter lasted longer. A drought arrived unexpectedly. These events were remembered because they altered the course of life. They created turning points not only for individuals but for entire communities. Over generations, these memories formed a collective understanding of how the world behaved. The idea that something beyond the Earth played a role in these changes grew out of observation rather than imagination. When parts of the sky looked different, when certain stars rose in unexpected places, or when celestial objects appeared bright and unfamiliar, people noticed. They integrated these observations into the stories that explain the world. These stories survived because they contained useful knowledge. They helped people anticipate change and adapt. Even as cultures transformed, these stories remained because the world continued to show patterns that resembled those described in earlier times. As centuries passed and civilizations expanded, writing systems emerged. Written texts preserved details that oral traditions might have lost. Clay tablets, scrolls, and inscriptions captured early attempts to understand cycles of nature. They recorded floods, storms, droughts, and cold periods. They described eras when the world seemed stable, and eras when stability broke. They preserved observations linking unusual environmental events with unusual celestial activity. These records provide continuity between ancient experience and modern research. They show that the idea of long cycles was not an invention of one culture, but a response shared across many regions. The endurance of this idea across time reflects the structure of memory. Humans remember events that challenge stability more vividly than events that confirm it. When the world behaves predictably, life continues quietly. When the world shifts suddenly, memory strengthens. These memories become stories. Stories become traditions. Traditions guide behavior. Even when the original event fades, the framework remains. This framework becomes part of how cultures understand the world. The idea of long cycles survived because it helped people navigate uncertainty. When modern science emerged, it brought tools capable of measuring time, space, and matter with precision never imagined by earlier civilizations. These tools revealed patterns hidden in ice cores, sediments, fossils, and astronomical observations. Some of these patterns mirrored the cycles preserved in ancient narratives. Sudden climate shifts appeared in layers of ice. Flood deposits accumulated at similar times in distant regions. Magnetic reversals aligned with periods of environmental stress. Comet debris appeared in layers associated with cooling events. These findings did not confirm every detail of ancient stories, but supported the underlying idea that the Earth experiences recurring disruptions. The continuity between ancient memory and scientific discovery demonstrates why the idea persists. It connects emotional truths preserved in cultural memory with physical truths preserved in geological records. It shows that the instincts of early observers were grounded in real patterns. Even when explanations differed, the recognition of cycles remained accurate. This shared recognition across time lends credibility to the idea and explains its lasting resonance. The persistence of this idea also reflects the human desire for orientation. People navigate life by identifying patterns. When patterns extend beyond immediate experience, they offer context for uncertainty. The idea that the world moves through long rhythms provides comfort because it frames change as part of a larger process rather than a sign of chaos. Ancient people used this framework to interpret their environment. Modern people use it to interpret scientific data. The language differs, but the purpose is similar. This idea also endures because it bridges the gap between knowledge and humility. It suggests that the world contains forces too large to control or predict completely. This recognition encourages respect for nature and awareness of humanity's place within it. Ancient cultures expressed this awareness through stories of gods or celestial beings. Modern science expresses it through models and equations. In both cases, the underlying message is the same. The Earth participates in cycles larger than any individual or civilization. The idea remains relevant because the world continues to change in ways that reflect long-term patterns. temperatures shift, ice melts, rainfall patterns move from one region to another, oceans warm in some areas and cool in others, winds strengthen or weaken. Data models show fluctuations that resemble earlier transitions recorded in natural archives. These changes remind people that the world does not move in a straight line. It moves in arcs and waves. These arcs resemble the cycles preserved in ancient stories. This resonance between ancient memory and modern observation draws people back to the idea repeatedly. They sense that the world today shares characteristics with earlier periods described in myth. They see floods, fires, and storms, and recall stories of earlier ages shaped by similar forces. They read scientific reports describing abrupt changes and notice parallels with historical accounts. These parallels reinforce the idea that cycles continue. The idea also persists because it offers a way to think about the future without treating it as entirely unknown. If the world has moved through cycles before, it may move through them again. This does not predict specific outcomes, but offers a framework for understanding broad patterns. It suggests that change will come, but also that humanity has endured change many times. It encourages long-term thinking, adaptation, and resilience. It positions humanity within a larger story rather than at the centre of one. Another reason the idea still echoes is that it connects different fields of knowledge. Archaeology, geology, climatology, mythology, and astronomy all contribute to the understanding of cycles. Each field provides pieces of a puzzle. When combined, these pieces reveal a larger picture. This interdisciplinary nature strengthens the idea as it draws support from multiple directions. It helps bridge the gap between past and present, between story and science, between emotion and observation. The endurance of this idea also reflects the structure of the human mind. People find meaning in patterns. They seek coherence in the world. They build narratives that help them understand their place in time. The idea of long cycles aligns with these tendencies. It provides a narrative that connects generations. It explains why civilizations rise and fall. It explains why landscapes transform. It explains why the sky sometimes behaves differently. It offers a way to understand time on scales far beyond an individual life. This idea continues because it is neither entirely proven nor entirely dismissed. It occupies a space where curiosity can remain active. It invites exploration without demanding certainty. It allows science to refine understanding. It allows stories to preserve memory. It allows new generations to interpret old ideas through new frameworks. This openness ensures its continuity. The idea also endures because it speaks softly rather than forcefully. It does not require belief to remain relevant. It simply exists in the background of human thought, resurfacing whenever patterns in nature resemble patterns preserved in memory. It does not push itself into prominence. It settles quietly into the edges of awareness. It appears during moments of reflection, during times of change, or when the world feels larger than usual. As the modern world grows more complex, the idea gains renewed significance. Technological networks, global communication, and scientific monitoring systems reveal patterns unfolding across continents. The ability to observe the planet as a whole reinforces the sense that Earth behaves according to rhythms larger than immediate experience. These rhythms become visible in climate data, satellite imagery, and long-term models. They provide new ways to understand what ancient people described through myth. The connection between past and present becomes clearer with each discovery. Ice cores reveal stories similar to those recorded in early texts. Sediment layers confirm cycles of destruction and renewal remembered in oral traditions. Astronomical simulations reflect patterns that ancient alignments may have tracked. These connections create continuity across ages, making the idea feel familiar and enduring. People hold on to this idea because it grounds them. It suggests that change is part of a natural progression. It frames uncertainty within a broader pattern. It provides a way to understand the world without requiring complete knowledge. It reminds humanity that it participates in cycles far older than itself. It encourages awareness of time measured not in years but in ages. This idea also resonates because it acknowledges the fragility and resilience of civilization. It recognizes that societies rise through stability and fall through instability. It shows that collapse does not end the story. Rebuilding follows destruction. Renewal follows loss. This pattern mirrors the cycles observed in nature. It provides reassurance that even during periods of disruption, continuity remains possible. The idea stays alive because it connects people to something larger than themselves. It invites contemplation rather than fear. It adds depth to the perception of time. It suggests that humanity stands within a tapestry woven across eras, shaped by forces both visible and invisible. It creates a sense of belonging within the larger rhythms of earth and sky. As the story reaches its quiet end, this idea settles gently into the background once again. It rests in the space between certainty and possibility. It moves through time without urgency. It carries echoes of ancient memory and reflections of modern understanding. It offers perspective without demanding conclusions. And so the narrative drifts onward, following the slow, steady breath of ages that pass through the world without haste, leaving traces in stone, in soil, in sky, and in the stories that people continue to tell as they settle into the calm of the night.